Welcome everyone and thank you for joining. I'm Maria and I'm host for today's session. Our presenter for today's session will be Satish Katukam and Sharan Sampath. And also we have Vikram Datta and Abhishek Pal in the panelists to assist us with Q&A. Before we get started, few housekeeping rules to be noted. All participants will be muted upon entry. If you have any questions, please use the Q&A panel on the right side of the WebEx window. Your questions will be addressed during or towards the end of the session. At the end of the session, there will be a short survey which will pop up automatically. Please take up the survey as your response will help us to improve the quality and the effectiveness of the training and serve you better in the future. The slide deck and the recording will be shared to you within a week's time. Without any further delay, let me hand over to Satish. Over to you, Satish. Thank you.
Thank you, Maria. Hello, everyone. Good morning. Let me share my screen first. You can see my screen now.
Yes, please, we can.
Okay, let's start. So, hello, everyone. Good morning. Thanks for joining the session today. The session today is we are going to discuss what is Cisco Meeting Server and its features. So let's look at the detailed agenda. So this is a 2 days training program. In the day one, we are going to cover CMS basics and different platform options we have for installing CMS and their deployment options. Then we'll look at CMS certificates, in the deployment. So we'll look at how the certificate should look like, how do we generate, how do we now configure those certificates. Then we will go through with the CMS and UC integration, especially with the CUCM and BCS integration. We'll take you through the step-by-step integration process, and we will discuss in the detailed dial plan about incoming and outgoing rules on CMS. Then post that, we will help you to plan your upgrade to 3.0. Please note that this training is designed based on 3.0 version, which is the latest version. So we have a lot of changes happen from the earlier 2.x version to 3.0. So we will help you to understand what are those changes, and we will help you in planning your upgrade to 3.0. Then we will take you through the new features which are introduced in 3.0 and 3.1 versions, and post that would be covering a detail about how the new WebRTC app will work, which is also known as WebBridge 3. That's the day one agenda. And day two, we will start with the APIs. Now APIs are integrated into the CMS web interface itself. So we'll take you through the API configuration, and then we'll discuss one of the cool features which we have is call bridge grouping for load balancing the CMS calls. Then post that, we will discuss about the next generation SIP recorder and streamer. The previous SIP recorder and streamer is no more valid in 3.0. So we'll take you through the new SIP recorder and streamer. Then we will take you through the CMM smart licensing and the CMM and TMS integration for your scheduling. And then we will close the session with troubleshooting and logs. Okay, how do you troubleshoot the different types of issues in CMS, and how do we collect logs in case if it is required for tax case. Okay, so this is the agenda for next 2 days. I hope you will find it useful. Okay, so without further delay, we will start. So we'll start with CMS basics, now to understand what is CMS and what are the different platforms we have and different deployment models. Okay, CMS. CMS is known for audio and video conferencing. So it does audio conferencing and video conferencing. Apart from that, it does a lot of other features. It's not just a conferencing device. It provides you a different functionalities as well, Like you can do web conferencing if you have a browser-based WebRTC calls. You can still join into the CMS meetings. The other cool feature with CMS is it acts as an interoperability gateway. Okay, when you are doing an interop with Skype, the CMS will provide you an interoperability so that like the standard SIP messages will be converted into MS SIP, Microsoft SIP. So this will act as an interoperability gateway. Then CMS provides you a recording and streaming functionality in case if you have a requirement to enable the recording or stream your meetings. CMS will provide you that feature. And then finally, it supports the customization. Okay, the customization comes in different ways, wherein you can customize your IVR prompts, you can customize your the WebRTC landing page. So there are different ways of doing the customization. You can do the customization as well. CMS supports different types of endpoints. Whether you have a Cisco endpoint, whether you have a third-party endpoint, doesn't matter. It supports every type of endpoint, a single screen endpoint, a multi-screen endpoint, doesn't matter. It supports different browsers when you are making a WebRTC call. Like it supports Chrome, Firefox, Safari, Microsoft Edge. So all the latest browsers are supported for making WebRTC calls into the CMS. You can use soft clients like Microsoft Skype for Business client. You can use the Java client for making calls into CMS. You can use the single screen endpoint or multi-screen endpoint, doesn't matter. Any endpoint you have, it can be a PSTN phone as well. You can use your mobile phone to dial into your CMS meeting as an audio participant. So irrespective of the endpoint, the CMS provides the consistent experience to everyone in the meetings. Also, it supports different types of meetings. So the meetings need not to be a scheduled meeting. It can be any type of meeting, like like a personal meeting. Every individual in the organization can have their own personal meeting, so that anyone can join to the meeting without scheduling. The meetings are always available to join, and you can simply dial the meeting number and join anytime. There is a meeting. It's also possible that you can join scheduled spaces or scheduled meetings. We can leverage our Cisco TMS for scheduling the meetings. It can be integrated with Outlook and schedule the meeting on CMS, and participants can join into the scheduled meetings. It also supports the ad hoc meetings with your call manager. It can register with the call manager as a conference bridge, and can be added to media resource group and assigned to the endpoint so that it will support your ad hoc calls. The ad hoc calls are possible only with the UCM. It's not possible with the expressway setup. Then finally, it supports the Skype meetings. You can have the Skype meeting scheduled on the Skype side, and CMS will help you to do the interrupt for you so that you can join into the Skype meetings, which is also known as dual home meetings. So in summary, Cisco Meeting Server provides you an audio, video, and web conferencing, which meets the collaboration needs for every individual. It allows anyone to join or anyone to create the meeting from any system, being it a mobile client or being it a browser, it doesn't matter. The best thing is that it provides you a consistent experience on every platform which you use. So that's a little bit about the CMS and its features. So let's look at the different platform options available for installing the CMS. Primarily, CMS comes in 3 different platforms. Okay, the first platform is X server, which is currently an end of sale. We are no more selling the X series platforms, but we have a lot of deployments available in the market which are running on X series. Okay, and then we have a second platform called CMS 1000 and CMS 2000. These are the preferred platforms in case if you are deploying the CMS. And then we also have a specification based servers, like you can have any hardware from any vendor, and you can install CMS on top of those hardware. So only thing is that you need to meet the minimum requirements for the software to be installed. So we'll look at those options in detail in the upcoming slides. X series servers, it is like end of support, so I will try to cover a couple of slides to explaining the features which the X series has. So X series comes in three different models: X1, X2, and X3. So the only difference is that like the number of processors and the maximum load it takes. X3 being in highest in terms of the processors, and it takes the highest number of calls. So it can be used as a core server, wherein your X1, X2 can be used as edge servers. We will see what is core and edge in the next slides. But as of now, just understand that X1 server can be used as a core server, and X2 and X1 can be used as your edge servers. In the slides, you can see the raised side of your X series servers. Obviously, it has redundant power supplies and redundant fan rest. But the idea here is to show this particular diagram that it comes with four different interfaces. So as you can see here, interface A, interface B, C, and D. Okay, and along with that, we have an admin interface. Admin interface is typically used for managing your CMS configuration, but wherein admin, the interface A to D are used for your traffic. Like when you are making a call, either the traffic can come to CMS on any one of these interfaces based on your configuration. So in some of the deployments, we might be using more than one interface at a time. But in many of the interfaces, many of the deployments, we recommend to use the interface A. So when you use the more than one interface, it's like when you wanted to have your CMS deployed in a network, like where you have interface A will be available for your internal users. Like you can configure with your local LAN so that your internal users can reach to CMS on interface A, and interface B can be available for your internet-based users. So you can assign a direct public IP address to interface B, and you can have your interface. You can have your external participants join in CMS meetings using interface B. Though it's not a recommended way, we have an expressway C and E solution in place, but there is an option wherein you can allow your external parties directly join in CMS. And this slide, the main reason to show you this slide is that there is an option on X series servers to reset the password. If you forgot the password for CMS on X series, we have an option to reset the password. But if you forgot the password on CMS 1000 or any other platform, there is no way to reset the password. Okay, you have to upload your previous known good backup where you know the password. Otherwise, the only way to recover is to by factory resetting the server. So this is one of the unique feature on CMS on X series servers. So there is if you open the top cover, there is an option you can just click on the red color button. Then it will allow you to log in without having without providing the password, and then you can set the password once you log into the console. That will be available for first 4 minutes. You can do that anytime without interrupting your services. So this is unique to X series servers. Okay, this is a comparison chart like to explain how much the capacity these servers can take. X3 will be supporting 250 HD calls with 720 30 FPS. The X1, X2 supports lower capacity than X3 servers. Okay, as I said, like X series servers are no more in sale. They are end of sale. Okay, so the new deployments will happen either on CMS 1000 or CMS 2000. Okay, let's move on with the CMS 1000. So CMS 1000 is a UCS based server, UCS based C series servers. It's a C220. Currently, we are selling C220 M5 series. Previously, it used to be M4 series. Now it is an M5 series. It is a one rack unit server. You can install you can mount it in a rack with one rack unit space. It comes with a pre-installed CMS software. Okay, so when you order CMS 1000 as a bundle, it comes with the pre-installed software, so you can just uh, uh, configure it and use it. You don't have to worry anything about your VM installations, like your ESX installation, or installing the software. It comes with the bundle already installed. So it comes with currently we are shipping, I think, ESXi 6.5 version. Earlier we used to ship with 6.0. So it supports any version which is 6.0 and above. It comes with 70 hyper-threaded cores, 70 virtual CPUs, and core residency is not supported. That means you cannot install any other software on CMS along with the CMS. Okay, it has to be dedicated to the CMS software. In a redundant deploys, you can combine CMS 1000 and X series servers in case of if you are doing the clustering setup. That means your deployment can have a mix of servers and appliance on X series servers as well as on CMS 1000. But however, one thing to keep a note, the backup from one server cannot be restored on another server. That means if you have a backup of X series server, you cannot restore that backup on CMS 1000 because both are on different platforms. You cannot install the backup from one model to another model. It has to be restored on the same model. This is the comparison chart for the load capacity. CMS 1000 with M4 series supports 96 HD calls, wherein we have a legacy hardware called Cisco Multi-Party Media Server portal. We used to ship this particular hardware for our earlier TPS servers, telepresence servers. So you have an option to use those hardwares to install the CMS. In that case, you will be getting the capacity of 64 high definition calls on 410 servers. So between the difference between M4 and M5 is the number of audio calls it supports. M4 server supports 1700 audio calls, wherein M5 server supports 220 calls, 2200 calls. The next platform is CMS 2000. This is primarily designed for service provider networks or the large enterprise networks. It comes with a chassis. It has a chassis and comes with 8 blades inside the chassis. It's based on UCS 5000 series hardware, and the blades are B200 series blades. It supports 700 HD calls. So if you compare with CMS 1000 and CMS 2000, there is approximately 7 times more capacity on CMS 2000. Your CMS 1000 supports 96 calls, wherein CMS 2000 supports 700 HD calls on one server. It's not a virtual hardware, it is a bare metal platform. Okay, so in a redundant deploys, we can do the clustering. We support up to 8 servers in a clustering, but you can go up to 24 servers. Like if you are during the clustering, you can you can have 24 servers in a cluster. But in case if you are going with more than 8 servers in a cluster, we need to validate the design. Like the Cisco BU has to validate your, and then you can have a number of servers. So the recommended clustering is 8 servers, but you can go beyond that up to 24. But the design has to be validated by the Cisco BU. So all 8 blades on CMS comes as a single unit. So that means you cannot buy like for example, you wanted to buy like 2 blades in this particular hardware. It's not possible. You have to buy this as a bundle, and all 8 blades comes as a single unit. So again, it can be clustered with a CMS 1000 or CMS 2000. So you can have a mix of devices in your deployment. The another type of hardware is the specification based servers. So that means you can have any vendor hardware by meeting the minimum requirements. So the minimum requirement for the processor is 2.5 gigahertz speed, and the memory should be 1 GB per core, and the minimum requirement is 4 GB. So you can have a 4 GB minimum RAM and 100 GB storage. It requires ESXi software 7.0 if you're deploying 3.0 version, but the older versions will support 6.0 and 6.5 as well.
Sorry to interrupt, Satish. The screen is not changing. We are still in Cisco Meeting Server 2000 with the products there.
Okay. Hold on, let me reshare again. You see now?
Yes, now it's changing.
Okay, sorry, I had to disconnect my VPN. Cool. Let's move on. So those are the 3 platforms as we discussed. X series servers, which are no more in sale, and the preferred platforms are CMS 1000 or CMS 2000. Or you have an option to go with the third-party hardware as well. So there are 3 platforms we have for the CMS installation. So on with the next topic is the CMS deployment models and the configuration part. CMS comes with 3 different deployment models. Okay, the first one is single combined server, the second one is single spread server, and the third one is scalable and resilient servers. Let's look at these deployments in detail. Before we go and discuss about the deployments, let's look at some of the modules available in CMS. CMS comes in a module way of configuration. Okay, it gives you a more flexible way of configuring your CMS. So there are different modules available which provides a different functionality to CMS. Okay, for example, like if you wanted to have your CMS only for audio and video conferencing, and you don't want to enable any other thing, you can just go and enable only those modules so that your CMS will support that functionality. Or if you want to have your CMS to support the audio video along with the recorder, you can go and enable those specific modules. So this module configuration gives you a more flexibility to choose what you want in your deployment and where you want them to be configured in your deployment. Okay, that's the reason that we have the modules to be introduced in CMS. So these are the different modules available in CMS. The module is a web admin module. Okay, it enables you the web interface for the CMS. By default, when you install and configure the CMS, the web access to the CMS is disabled. Until you enable the web admin, you won't be getting the access to the web interface. Okay, so the first module which you need to configure is web admin that will provide you the web GUI access. The second one is the call bridge. This is the primary component in the CMS solution. Okay, this is the module which provides you the conferencing facility. It provides you like it will mix your audio and video into a single stream, and this kind of in the heart of the solution. And the next component is the database component. It is a place where the information about your meetings, information about your configuration will be stored. The next module is the web bridge module. It provides you a WebRTC based calls. Like it enables you to have the WebRTC based clients joining into your meetings. Recorder and streamer, as the name suggests, it enables you the recording and streaming of your meetings. The turn server provides you the firewall traversal solution in case if you are having your clients behind NAT, wherein they cannot directly communicate with the call bridges. The turn server will provide you a way of connecting connecting the media between the call bridge and the endpoints. There are a few additional modules we have in the older versions like an XMPP module and the load balancing and trunk modules. We are not recommending those modules anymore. In fact, those modules has been removed on 3.0 versions. If you are having older versions, you can still see those modules, but on the newer versions, these modules are removed. So XMPP is basically provided a functionality for your CMA client if you're using Cisco Meeting app on base clients. So it requires an XMPP component to be configured. And we have a load balancer trunks. These two modules is kind of an act as a proxy for your internal XMPP server, providing you a secure firewall traversal for external CMA clients. But these two are not recommended anymore to use. Okay, so now let's move on to the deployment types. So the first deployment type is single combined server deployment. As the name suggests, it's a single server. All the modules, whatever we discussed so far, are configured in the same box. This deployment type is recommended for your lab setup or your kind of a POC setup. It is not recommended for your production environment because there is no redundant feature on this particular server. If the server goes down, your conference will fail. So this is not recommended for your production deployment. And they will be integrated with Expressway C and Expressway E in case if you wanted to have the traversal solution. So as you see, all the components, your call bridge, your web bridge, database, and web admin, everything is installed in the same server and will be talking to your call bridge component. So this is the primary component. All other components would be talking to the call bridge component. The second deployment is a split server deployment. As the name suggests, as the name says, we would be splitting the components into two servers. One is a core server, which will be residing on your internal network. And the second one is an edge server, which will be sitting in your DMZ network. So on the core server, we would be enabling the call bridge and database components along with your web admin. And on the edge server, we require to enable the web bridge and the turn components. So your web bridge and turn will be configured with the public IP address so that they can be accessible from outside of your network, wherein your call bridge will be available for your internal connections so that your endpoints can directly connect into the core server meetings. The third deployment is scalable and resiliency deployment. So this is the most preferred deployment if you're going for the productions, right? So in this, you can have multiple core servers. They're working together to provide you a resiliency as well as scalability. So when we say scalability, so each server has its own limitations. Like when you take a CMS 1000, it has 96 calls as a limitation for for the HT calls. If you require to have more than 96 calls, then obviously you need to have one more server to be deployed. So that way you can have like multiple servers. You can go up to 24 servers. That is what we support in the call bridge clustering. But what we recommend is that after 8, if you are going more than 8 servers in deployment, it is required the design to be validated by Cisco VU. So you can have more number of, multiple core servers, and it also provides you a resiliency. Like in case if one server goes down, you will have the same features configured on the other server so that the other servers will take over your meetings. So in this deployment, we require to have the configuration for clustering. The database has to be clustered, and you can have database servers installed on multiple servers. And call bridge can be clustered. The call bridge can be installed on multiple servers. And similarly, you can have the bridge component enabled on the multiple servers. The bridge doesn't support a clustering, but you can do a failover using your DNS configuration. Okay, so some more details about the database clustering. So when you are doing the database clustering, so database will be having the configuration of your CMS meetings and configuration of your CMS users. So all the information will be stored in a database. So the call bridges which are hosting the meetings will be connected to the database component, which is a primary server, and can have read and write access to it. So in a database clustering, you can have one master and multiple slaves. So you can build the database clustering with a maximum of 5 nodes, and it has to be in the odd number. That means you can have either 3 servers in a database clustering or 5 servers in a database clustering. You cannot go with the even number of database servers. That means you cannot have 2 servers or 4 servers. That will not give you the redundant setup. If you go with 2 or 4, your failover will not work. It's always recommended to have in odd numbers, which means 3 or 5. And we don't require to be configured. We don't require more than 5 servers to be configured for database in a clustering setup. So call bridges always connects to a master server. In case the master server goes down, the other servers will be elected as a master, and all the call bridge server will connect to a new master server, which is elected during the failover process. Some of the key points. So CMS use Postgres as a database. It uses port 5432 when the database are connecting each other. So by default, the database component will be installed on all the servers. There is no specific software to be installed. It comes along with your call bridge configurations. So database can be deployed on a standalone servers, or in case if you are going with 2 call bridge servers with a clustering setup, so you can install database in a standalone server with lower capacity or lower specifications. While you're configuring the database, we must need to configure the database cluster along with the certificates. We will see that in detail in the next slides. But certificates are mandatory when you are deploying the database cluster. So if you are planning to go with call bridge clustering, obviously you require database clustering to be configured first. Once you configure database clustering, then only you can enable the call bridge clustering. So without database clustering, call-based clustering is not possible. So there is a procedure while you are upgrading your database clustering. When you're upgrading CMS servers, there is a sequence which you need to follow. Like you need to upgrade your non-database servers first, followed by database slave servers. And at the end, we need to upgrade the database master server. And once you upgrade, we must need to issue the cluster database cluster schema upgrade command on your master server. So there are keep alives exchange between the database servers. If 5 keep alives fails, that server is considered as dead, and it will be removed from the database clustering configuration, and other server will be elected as a new master server. The election process is completely decided by the CMS itself. We don't have any control like which one can be a master in failover scenario. Automatically, one server will be promoted as a master, and when your dead server comes back online, it will comes back as a slave server, even though it was its role was a master in previously. But when it is dead and comes back, it will comes back as slave server. For failover to happen, it approximately takes 10 to 15 seconds. It's kind of like seamless. You don't even notice until unless you go and check who is the master. It will happen very quickly within 10 to 15 seconds. The new master will be elected. So as I said, we support maximum of 5 nodes in a database clustering. There is no need that you can go on more than 5 nodes. And it has to be always in the odd number. The recommended latency between the database servers is 200 milliseconds or less. So if you're doing the geographical database clustering, make sure that your servers should be having a round trip delay of less than 200 milliseconds. Similarly, we can do the call bridge clustering as well. Like once you enable the database clustering, we can go ahead and enable the call bridge clustering. This is to provide you the resiliency again, resiliency and scalability. So in a call bridge clustering setup, if your meeting is hosted on multiple servers, there will be an intelligent cascade link exchange or cascade link connects between those two call bridges, so that the participants, even though they're joining on 2 different servers, they will be connected to each other. They can see each other. So in this example, if you see that, like the participants in London are connected to the London call bridge, wherein the participants in Hong Kong are connected to the Hong Kong call bridge. So since they are connected to the same meeting, okay, even though they are hosted on 2 different servers, but they are connected to the same meeting, the database will be knowing that, okay, there are meetings happening on 2 different servers for the same meeting. So it will initiate an intelligent cascade link between these 2 call bridges, so that the participants can see each other, can talk each other. So this happens automatically. You don't need to do any manual thing for that. Like once you set up your clustering properly, this will happen automatically. But some of the key points when you're doing the call bridge clustering. So it can be clustered for allowing your distributed meetings. Basically, like if the meeting is happening on 2 different servers, there will be a distributed link established between them. So for the call bridge clustering to be enabled, you must need to enable the database clustering. That is the primary requirement, and all the information, whatever you have on one call bridge will be carried forward to other call bridge. That means, like if you are muting one participants on one CMS server, that can be updated to the other meeting server on the other call bridges. So all the call bridges will access to the same master database. And if that master goes down, all the call bridges will shift to another master within the cluster. Okay, that's about the deployments. Let's look at the configurations. Like, how do you configure all these modules, whatever we discussed so far. So the first module to be enabled as soon as you configure the CMS server is web admin. And by default, you only get the console access. We need to set up the IP address for the initial configuration and then go ahead and enable the web admin module that will enable the web interface for your CMS server. So this is also required for some of the other configuration for your call bridge, like to set up the inbound and outbound rules, for setting up your clustering configuration, and also it is required for monitoring different services or to collect the logs and setting the diagnostics levels. So how do we configure the web admin? So on the CLI, you can just type these three commands like web admin listen, interface, and the port number. If you remember, I was talking about like 4 different interfaces on CMS, right? So you need to mention on which interface the web admin is going to listen. Okay. So for example, web admin listen interface A. So you have to type a small alphabet A. So that is your interface A, and followed by the port number. So by default, web admin listens on HTTPS. If you don't mention the port number, it will be using 443 as a default port. And then mandatorily, you need to enable, you need to configure the certificates, web admin certificates, and the key file and the certificate. And finally, use web admin enable command to enable the web admin. In some configurations, in some deployments, we might need to change the web admin port because if you enable WebBridge also on the same server, WebBridge also runs on port 443. So there will be a port conflict. So you might need to change this port to a different port like 445 or 8443, in case of conflict. And the next component to be configured is the call bridge. Call bridge, as I said, it's a primary component in a solution. It must need to be exist somewhere in the deployment. That means without configuring the call bridge, your CMS functionality will not work. That means your audio and video conferences will not work. It's a media processing engine. All the media streams, audio and video streams, will be mixed by this particular component at this particular module. And this is an API integration points. That means all API commands that you're sending will be sent to Callbridge, and Callbridge will decide how to respond to those API messages. It's a call processing and routing component. So all the intelligent will reside on the Callbridge component. So all the call routing information, like where to connect your calls, how to forward your calls, how to send your outbound calls. So all the routing logic happens on the call bridge. It can be brandable. That means your audio and video prompts can be customized. It supports clustering for your distributed calls. So how do you configure the web bridge? It's again like simple 3 CLI commands. You can log into this CMS using a CLI and enable these 3 commands. Again, you need to mention the listen interface, call bridge listen interface A. It is possible that this component can listen on multiple interfaces. So if you decide to choose, if you decide to enable multiple interfaces on CMS, like interface A for your internal users and interface B for your external users, so you can configure call bridge listen A space B. So it listens on both interfaces. And since the call bridge supports the SIP traffic, by default, it listens on 5060 and 5061. So both these ports required for the call bridge. And then configure the certificates, key file and the certificates, and then enable your call bridge by using call bridge restart command. The next component is WebBridge component. In case if you have a requirement to provide a WebRTC based solutions, that means like browser based calls, you need to enable the WebBridge component. Okay, if your requirement doesn't says that you need to have a WebRTC based call, you don't need to configure this component. You can simply use CallBridge and you can make your SIP participants connected to the CallBridge and to the meetings. So the WebBridge is primarily for your WebRTC based clients. It works on using a web apps on HTML5 compliance process. So all the latest process will be an HTML5 compliance process. Like you can use your Chrome, Firefox, Safari, and MS Edge. But what we prefer is Chrome. Chrome is the browser which we prefer, but it's up to you, which browser you wanted to use. But you make sure that you have a latest version of your browser. It's based on the WebSockets and the WebRTC standards for audio and video. So it uses WebSockets and the WebRTC. It allows you to join your guest, okay, using a link. Now, so for your guests, like your partners, your suppliers, your customers, they can simply join using a URL link which you provide. They will just take that link and open the browser, and they will be able to join in your meetings. It's as simple as that. By default, WebBridge supports on port 443. But if you have web admin component or web admin module, which we discussed in our 2 slides back, so both of them listens on same port number, like 443. So you must need to change the port number either for a web admin or for a WebBridge. You cannot use both on the same port. It will, as soon as you try to enable, it will give you an error that port is already in use. Okay, so the WebBridge configuration, this is a new configuration. Previously we used to have WebBridge 2 in the older versions until 2.9, but from 3.0 onwards, we have moved to WebBridge 3. Okay, so it has a bit more steps when you are doing the configuration compared to your previous WebBridge 2 configuration. So the configuration goes in 3 steps. If you see, the first 2 commands are step 1. It's like you have to enable the HTTPS listen interface and the port number and the certificate. So the first 2 steps are for your browser to connect to the WebBridge 3 component. Okay, so the browser, when you open and you type the URL, so it's going to connect to the listen interface, whatever you mentioned, on the port which you configure here. And then it will try to look at these certificates which you configured. And once that is done, the next 2 steps are next 2 commands are to connect the communication between your CallBridge and WebBridge, which is also known as C2W connection. Okay, you need to set up the interface and port number for your CallBridge to WebBridge connection. C2W listen interface and the port number. So this port number can be an internal port number. You can use any port, but make sure that your CallBridge and WebBridge can talk, can reach on that particular port. For example, you can say WebBridge 3 C2W listen interface A and port 9999, or you can use 8443. Any port, but make sure that this port is reachable. And then specify the certificates so that your CallBridge and WebBridge can connect each other. And the third step is to enable the trust store between your WebBridge and the CallBridge. So you need to configure WebBridge 3 C2W trust and the bundle of your CallBridge certificates. This bundle will be the certificates of your CallBridge plus the root CA, the CA certificate who signed the CallBridge certificate. It has to be bundled. If you have intermediate certificate, you need to bundle them as well. And then finally enable the WebBridge 3. This will enable your WebBridge 3. So once this part is done, we need to go to your CallBridge component and configure the trust store between your CallBridge and WebBridge again. Okay, and this has to be your CA bundle, which you configure for the WebBridge 3 certificates. Okay, and then finally restart your CallBridge service, CallBridge module. So we have a specific slides only to cover the WebBridge 3. I think later today, before we end the session, we have a detailed session only to cover the WebBridge 3 or the WebRTC app. Okay, so once that is done, there's another final configuration which need to be configured via the API. Okay, we need to mention the URL for a call bridge to know where the web bridge is configured. So the URL has to be in a format like C2W // FQDN or IP address of your web bridge and the port number. And we need to make sure that this FQDN, whatever you mentioned, FQDN or IP address, should be present as a common name or as a subject alternate name in your certificates. Okay, if you don't have that name present in your certificate, you won't be able to get the web bridge up and running. It will give you an error that the certificates are not trusted, something like that. Okay, the next component to be configured is turn server. This is an optional configuration in case if you are using the Expressway solution, and if you enable turn server on Expressway, you don't need to enable the turn server on CMS, but we have an option to enable and use the turn server on CMS itself. So this is required in case if your clients are outside of your company and they're not able to reach your call bridge directly. Like now, if your clients are in a private network and your call bridge is in a different network, both cannot talk each other directly. We require to have turn server for providing the NAT traversal, and it provides you a media path between two clients, and it's both H33 and SIP capable. That means you can have a SIP endpoints as well as H33 endpoint can use the turn feature. One thing to note here is that generally when you talk about the media is always on UDP, right? It's always sent on a UDP packets, but the WebRTC browsers, like the browsers like your Chrome or your Firefox, whoever is having an HTML5 compliance or whoever is having the WebRTC support, they are capable to send the media over TCP. In case if your firewall is not allowing the UDP traffic, the firewalls might be closed for the UDP traffic, they did not allow the entire UDP range for media, the browsers will fall back to send the media over TCP port. Okay, so the turn server, whether you use it on Expressway or on CMS, will receive the media on TCP port, and it will convert that back to UDP and send it to your call bridge. So this will be useful now if you're trying to connect to CMS over a public internet. You can't expect in a public internet that UDP ports are opened. In many of the public Wi-Fi's are hotspots, the UDP traffic is by default disabled. So this feature will enable to use TCP as a media. So if you decide to choose turn server on CMS, we need to configure it first on CMS. To configure that, you again need to set up the listen interface and the credentials for your turn, username, password, and the turn domain, and enable. And we need to specify the turn public IP address, because turn is basically for your clients who are outside of your company, right? So they need to reach the turn server using a public IP address. You need to specify your public IP address and specify the TLS port. Again, this is by default uses 443 port. In case if you are having a conflict with a web admin or web bridge, we recommend you to change the turn TLS port here. You can choose a different port like 445 or 447, whatever port is needed. And then you need to mention the turn server details and CMS either from web interface or from API. We recommend to use APIs to configure the turn server details on CMS. So when you configure turn server, you need to specify two addresses. The first address would be turn server address for the server. That means the turn server address for CMS itself, like to say where the CMS will send the media to. And then the next address will be turn server address for the clients. This is the address for your clients, which typically are the public IP address. That means the clients outside of your company will send the traffic to this public IP address, wherein CMS internally will send the traffic to the internal address. So typically the turn server will be listening on two interfaces, internal interface and the external interface. So this is how we consider it. The TMS listen interface would be your internal interface and the public IP would be your external interface. And then configure your username and password. The next is database clustering configuration. In case of your resiliency setup, you must need to set up the database clustering. There are simple, just 3 steps. So you need to enable the local node for your cluster. So database cluster local node interface A. So this is the interface which will be participate in the database clustering. And then you need to set up the certificates. There are 2 types of certificates available when certificates are required when you configure database server certificate and database client certificate. And then the CA certificate. Then you need to choose, when you are doing the initial configuration, you need to choose one server as your database master server. And on the master server, you need to initialize the clustering configuration. So on master, you need to run database cluster initialize. And on your other slave servers, they need to join into the master servers. It means you need to run on slave servers database cluster join IP address of your master server. And then finally, check the status. So you should be seeing the database cluster status as connected with your all peer nodes. So some of the best practices when you are doing the database clustering, make sure that you issue the database cluster upgrade schema command on every upgrade. Okay, when you are upgrading from your previous version to the new version, make sure that you issue this particular command. Otherwise, your post upgrade your calls will fail. The client certificate for your database should contain the common name as Postgres. If we are not doing this, you will get an error while you are initializing your database cluster. Make sure that you have the database clustering in odd numbers. So minimum 3 are required, maximum you can go up to 5 servers. In case when you're doing an upgrade, in case you decide you wanted to roll back to your previous version. So the rule here is that you can restore the old version backup to a newer version, but newer version backup cannot be installed on the older version. So that means if you have a backup of 2.7, that can be installed on 2.8, but if you have a backup of 2.8, you cannot install on 2.7. Okay, because the backward because the DB there are different schema, different tables are available for the different schema, so it's not supported to restore the backup of newer version on the older version. So all the nodes will have a keep alive check now to see if the nodes are alive or they are dead. If there are consecutive 5 keep alive space, that node will be considered as a dead and new master will be elected. So if the failover happens, you can see in the logs that the master has been failovered and the new master is elected. Once you finish your your database clustering configuration, then you can go ahead and enable the Callbridge clustering configuration. It's very simple. You can just go to the configuration and clustering tab, and you can mention the unique name. The unique name should be unique for each server. If you have 3 servers in a cluster, the unique name has to be different on all 3 servers. And then go to the clustered callback setup and add all your servers into the cluster. So when you're adding, you need to make sure that you add with an IP address or FQDN along with your web admin port number. So it has to be HTTPS as a transport, IP address or the FQDN along with your port number, the web admin design port number. And once you had, make sure that your connection is active and the hard bits are exchanged. Another important thing in the call-based clustering, once you finish the clustering configuration, make sure that you set up the outbound rules. So we see, many of the attack cases, you set up a call-based clustering, but you forget to add the outbound rules. So if you forget to add the outbound rules for each of your call-based, so you need to set up a outbound rule for each one of your nodes. If you have 3 nodes, you need to have 3 outbound rules. If you have 4 nodes, you can have 4 rules, outbound rules. If you fail to do that, your distributed calls will fail, because in a distributed call, one call-based server will be dialing into another call-based server. If there is no outbound rules, the calls will fail. And you will be seeing clearly in a distributed environment, you will be seeing that one call-based server is making an outbound call to another call-based server, and other call-based server, you will be seeing that there is an incoming call for the same the call ID. So the outbound rules are very important when you're doing the call-based clustering. Yeah, that's it about the configurations. So we have discussed about the platforms and different deployment models and the configuration of each module. Now let's move on with the certificates. As you see, each module when you're configuring, it is mandatory that we are setting up the certificates, right? So without having the certificates, you cannot enable any of the component or any of the module. So certificates are essential while doing the CMS configuration. So the certificates can be as self-signed certificates or CA-signed certificates. Now, some components can run on self-signed certificate, and some components required to have a CA-signed certificate. Again, the CA-signed can be a internal CA or can be an external CA based on your modules. I'll discuss about which module is required internal CA and which module is required for external CA. We don't recommend you to use the self-signed certificate. We request or we recommend you to use the CA-signed certificates. So there are multiple options that are available for certificates. You can use a PKI command, and there are multiple commands that are available to check your certificates. PKI list, PKI inspect, PKI match. So to generate the self-signed certificates, we have a command called PKI self-sign, and you can give the certificate name. It will generate the certificate for you. Similarly, we have an option for PKI sign. Okay, the PKI sign is introduced, I guess, in 2.7 version, if I'm not wrong. So the PKI sign command, what it will do is that it will use your existing CSR certificate and sign your CSR. So that means you can generate a CSR, and then you can use one of your existing certificate, which is having a valid key and certificate, and sign that CSR using the certificate. And then you can use the PKI inspect command to see what is there in certificate, what is your CN name, what is your SAN entry, and who is signed it. So all the information can be seen by using the PKI inspect command. So how do you generate your CSR? The self-sign certificate. You can use the PKI self-sign and the web admin. This is your name of your certificate. So when you generate the certificates using self-sign, there will be 2 files generated: webadmin.key. Webadmin is your certificate name. So there will be a .key file and .crt file. CRT file is your certificate. Key is your private key. In self-signed certificate, we have an option to include the common name as well. Like, in the older versions, when you generate the web admin, when you generate the self-signed certificate, there is no option to include the common name. But in the latest versions, I guess from 2.7 onwards, we have an option to include the common name in self-signed certificates. So if you look at this, the PKI help command, so PKI self-sign, the certificate name, and you have an option to include your attributes. The attributes can be your common name, your organization, your location, your country. So all these things can be included here. And CA sign certificates. So for CA to sign, we must need to generate the CSR, the certificate signing request. So there is a command called PKI CSR, and then you can use this particular syntax, PKI CSR, name of your certificate, and the common name, and your other option fields like your OU, your organization, your state, country, and you have an option to include subject alternative names as well. So wherein you can add multiple FQDNs as part of your certificates. So this is an example which shows how to generate the certificates. PKI CSR, CMS Cert is the name of your certificate, and the common name is your core1.f your FQDN, which is cmslab.com. So this must be an FQDN and is typically your name of your server. And then you can have optional fields, organization unit, location, and country, and subject alternative names. So in subject alternative names, you can include your other URLs, such as your join URL or your clustering FQDN. So whatever alternative names you have for your server, you can include them in your subject alternative names. So when to use the self-signed certificate or when to use your CA-signed certificates. Okay. Any component which is internal to your server, that means which is not connecting outside of your network, can be used as your can be used with the self-signed certificate. For example, web admin. Web admin is your your internal service or internal module to access your web interface, right? So that can be configured with self-sign, but we really don't recommend to have self-sign certificate. At least you have a CA sign. At least you have an internal CA sign. Like you can use your company's Active Directory, to generate these certificates. If not, the public CA sign. So the web bridge component must need to have your public CA sign certificate, because you will be connecting it from outside using a browser. If you configure it with your internal CA or the self-sign, you will be prompted saying that your certificates are not trusted. You have to accept the risk and then connect. So the web bridge is required to have a public CA sign certificate, and TUN server is required to have your public CA sign certificate. And in case of link integrations, Skype integration must need to have a CA sign certificate configured for these components. So there is a guide, which is here. You can go to the guide, and there are detailed steps for each component. How do you generate the certificate? How do you generate your CSR? And how do you configure it? You can have a look at this particular link. Okay. That's it for this particular slide deck. So have a different slide deck to share for another topic. Okay, so the next topic we are going to discuss the UC integration. We'll see how CMS can be integrated with the call manager as well as with the expressway. So first we'll look at the CSM integration part. and then we'll go to expressway, and then we'll also discuss the dial plan overview, and we'll see how the incoming rules, outgoing rules, forwarding rules can set up in CMS. So there are two types of integrations possible with CUCM. One is rendezvous integration, rendezvous type integration, and the second one is ad hoc integration. So rendezvous is something like a meet me type of setup, like where you will be having a particular meeting number, and everybody will be dialing into that meeting number, and they will be participated in the meetings. Ad hoc calls are something like you will be having like a point-to-point conversation, and you suddenly realize that you need to include the third party. So you put you press the conference button on your phone on your endpoint, and then include the third party. So that will be the point-to-point call will be escalated to the multi-point call, which is also known as ad hoc conference calls. So for rendezvous calls, on CUCM side, we require to have a SIP trunk. SIP trunk can be a secure SIP trunk or a non-secure SIP trunk based on your requirement. In both scenarios, it will work. And then you can set up a route pattern and then associate the route pattern to your trunk directly, or associate your route pattern to a route list followed by a route group and the trunk. And on the CMS side, we need to set up an incoming rule to handle your calls from CUCM. So let's look at them in detail. So first, need to set up the SIP trunk from CUCM to CMS. Can be a secure SIP trunk, can be a non-secure SIP trunk, and then associate the route pattern. Okay. The trunk type should be SIP and can be a secure profile. If you are using a secure profile, 5061, we have to use a 5061, and we need to make sure that the certificates, the call bit certificate, need to upload into CUCM as a CUCM trust. And then you set up the destination SRV using 5061 port, and then make sure that you have a secure SIP trunk with the TLS enabled for incoming and outgoing, and the incoming port should be 5061. And then make sure that you add subject alternative name. So this must be your CMS FQDL. It must need to be present in the certificates and the call bit certificate, whatever you configure. And then create a route pattern. And the route pattern will be, this is basically a meeting number and CMS. And that meeting number, that route pattern will be associated to the trunk which you created. And on the CMS side, make sure that you have that particular meeting created. It's not like that you created a route pattern and there is no meeting exist with that particular pattern. So make sure that you create your meeting with that particular number, and then you can have a rule, an incoming rule matching to your spaces. So incoming rule, you need to make sure that the domain portion is matching, is basically your CMS own domain. When you're sending a call from CMS from CUCM, the call comes as like the meeting number @ the domain name. So the CMS will look for the domain portion of the call number, and it will try to match its incoming rule. If there is a match, it will go and connect to your spaces. For ad hoc calls to work, we again need to have a SIP trunk to be created on CMS, and along with the conference bridge and MRGs and MRGLs. So if you are using the call manager, older version of your call manager like 11.5 SU2 or below, you don't have an option to add the conference bridge directly as CMS, a Cisco meeting server. So in such cases, you can use the Cisco telepresence conductor to add it. But from 11 11.5 SU3 onwards, we have direct option to configure it as Cisco meeting server. Also, in the latest version, so suppose if you are using a latest version of your CMS, okay, and the older version of your call manager, the latest versions of the CMS will use by default TLS 1.2, wherein your call manager might be supporting TLS 1.0. So in such case, if you're trying to register the conference page uh, to CUCM, the registration will fail. Okay, you need to make sure that the TLS versions are matching. So these details are documented in the deployment scripts. You can just go ahead and refer to them. So you can choose the meeting, the conference bridge type as meeting server, and the SIP trunk, the SIP trunk which you created as to associated with your conference bridge. And then make sure that you have username and password. So this is your web admin username and password along with the port. So if you have changed the web admin port on CMS side, make sure that you use the appropriate port on conference bridge. Otherwise, the registration will fail. Okay, the certificates requirement when you're integrating with the CUCM. For rendezvous calls, as I said, it is optional in case if you are registering the if you are setting up the SIP trunk as non-secure, but it is required if you are setting up the SIP trunk as a secure. So in secure SIP trunk, the call bridge certificate and call bridge root CA certificate must need to upload into CUCM as a call manager trust. Okay, that is a requirement. For ad hoc calls, it's mandatory that you upload the certificates because we are connecting to the web admin on HTTPS ports. So this will always check the certificates. It is mandatory that you upload the web admin certificate and the web admin root CA certificate to call manager as a call manager trust certificates. Okay, if you have call manager and the CMS is signed by same root CA, you don't need to upload the root CA, you just need to upload the web admin certificate. If both of them are signed by different CAs, or if your call manager is having a self-signed certificate, you must need to upload both certificates, the web admin certificate and web admin root certificate. Otherwise, the call bridge will not register. And also another thing, important thing, that in case your SIP trunk is set up using an IP address, for example, a SIP trunk you choose set up using an IP address as a non-secure, then you must need to override the SIP trunk destination using an FQDN, and that FQDN must need to present in the certificates of your web admin. If you fail to do so, your conference bridge will never register. So that's about the CSM integration. Now let's look at the expressway integration. This is again fairly simple. For expressway integration, make sure that you set up the neighbor zone, okay, from expressway to CMS, and configure the search rule with an incoming leg and outgoing leg towards the CMS. And on the CMS side, again, we need the incoming rules to handle the calls. So how do we create a neighbor zone? Just go to the zones and create a new zone and choose the zone type as neighbor. And then make sure that you set up the, you choose H33 mode as off, because the CMS by default listens only on SIP. It will not listen on H33. And then you can have a secure neighbor zone or a non-secure neighbor zone. It's up to you what you wanted. If you are using a secure neighbor zone, again, we have an option whether you wanted to verify the certificates or you don't want to verify the certificates. So if you want to verify the certificates, make sure that TLS verify mode is set to on, otherwise choose off. And in the location address, make sure that you put your CMS IP address. We recommend in case of your clustering deployment, if your CMS is having a clustering setup, for each node in the cluster, we must need to set up a separate neighbor zone. So for example, if you have 3 nodes in your CMS, make sure that you have 3 neighbor zones set up from expressway. Okay, it's not like that you put all the nodes in one neighbor zone and you have one SIP trunk uh, pointing it to 3 different CMS servers. No, that's not recommended. Each server should have its own neighbor zone. And the zone profile should be custom, and make sure that you enable the meeting server load balancing on each zone. If you don't do that, your call bridge grouping feature will not work. Okay, once you set up the zone, make sure that you set up the schedule as well so that you can route your calls from expressway to CMS. So it's simple. The target should be your CMS, and you have your pattern match, or whatever dial plan you have. Make sure that you create your pattern string and point it to your CMS server. In case of troubleshooting, make sure that you enable the these traces on expressway side. SIP trunk tracing is required, and packet capture is required on CMS side. So CMS can enable the packet capture and CUCM logs and expressway diagnostics logs. If the conference bridge is not routing, we need to have your call manager traces and packet captures from CMS and CUCM side. Okay, now let's look at about the dial plans, how dial plans will work in CMS. So basically, dial plan. So basically, whenever the call comes to a CMS, now any incoming call comes to a CMS. So first, it will check the call which come to CMS is for CMS itself, or it needs to go out to a different destination, for example, to a Skype. So it will check the incoming call whether it is for its own spaces, users, or IVR, or it's for the link. So it will do the determination, and based on that, it will go to the stage 2 or step 2. If it is not for its own, it must need to use a forwarding rule to forward the call, for example, to a Skype or to a link. So in case of forwarding, it will use again an outbound rule. Okay, and the outbound rule, you have an option whether you wanted to modify your the domain or not. You decide that and then send the call to an outbound rule, and the outbound rule you can forward the call to destination. In case if it is required, you can apply your transforms, like modifying your number. You can modify your number using the transforms and send the call to outbound. So it's like incoming call, check whether you have whether that call is for CMS itself or it's required the forwarding. If it is required forwarding, then it will go to stage 3 or step 3, wherein it will check the outbound rules and send the call out using the outbound rules. So to explain that in detail, so when an incoming call comes, so it will check the matching domain. On the inbound rules, you have an option to match the domain. If there is if there is a matching domain and it says route the call to its own spaces or to the users, call will be routed to there. If not, then it will go to a forwarding option. So there are forwarding rules. In the forwarding rules, also we need to have a matching domain. If there is a matching domain, then you decide whether you wanted to do the call forwarding or you want to terminate. If there is no matching domain, the call will be terminated saying busy here. If there is a matching domain, then you choose to forward the call. Then there's an option to modify the forwarding domain before it route to the outbound rules. Okay. If not, you can terminate the call here itself. So once you decide what you want to do with your forwarding rules, then the call goes to an outbound rule and check the outbound rules whether there is any matching domain or not. If there is a matching domain, you have an option to send the call as it is, or you have an option to send the call like to in a pass-through mode or use dial plan mode. In a pass-through mode, the call will be directly forwarded as it is without modifying anything. But wherein if you choose a dial plan mode, you can modify your from domain and your contact domain based on your configuration, and finally send the call to your appropriate destination. So to see the detailed configuration of your local dial plan, like first on the inbound rules, this is how your inbound rules looks like. So there is a domain name portion wherein you can mention your domain name. Okay, so when a call incoming call comes in a valid SIP URI format, it will always look for the domain portion. Okay, so it will see if there is a domain portion matching here. If there is a matching, then you have an option to check the set the priority and then the target. So where you wanted to send this call, whether it is to a CMS space or to a user or to an IVR or to a link. Okay, you can choose it here. If there is no rule matching in the inbound call section, then the call will move forward and check if there is any rule at the call forwarding section. Again, in the call forwarding section, you have a domain portion to match the domain and the priority and the forwarding option, whether you can decide here whether you wanted to forward the call or reject the call here itself. If you choose to forward the call, and then you have an option to choose use dial plan or use pass-through. So as you see in here, you have an option to choose a pass-through mode or dial plan mode. If you choose a dial plan mode, the call, the from domain and the contact domain can be modified. But if you choose the pass-through mode, the call will directly go out to the destination. So that option can be configured here, and then redirect domain option. So whether you wanted to modify the domain here before you forwarding it using outbound rules, or you just wanted to leave it as it is. And then once the forwarding rule matches, then it goes to an outbound rule. On the outbound rule, again, we have a domain portion to match the outbound rules, and then use the SIP proxy address where you wanted to send the call. So this will be your destination address, can be your CUCM, can be your Skype address, or can be an expressway address based on your deployment. And then you have local contact domain and local from domain. This is basically to modify your SIP contact header and SIP from header. This is primarily required in case if you are dealing with your Skype integration. In some cases, you might need to modify your contact header and the from header in case of the link configuration. And then choose your trunk type. Can be a standard SIP trunk, or can be a standard link type trunk, or the aware type trunk. Behavior can be a continue or can be a stop. So if you choose the behavior as stop, only this rule will be matched. If you have any other rule below this with the lesser priority, the call will not look, the CMS will not look for those rules. So you can either continue the behavior or stop the behavior. If you choose continue, the CMS will go ahead and continue to look for other rules in the lower priority. Then you can choose the encryption type. Now auto is something it will first try with an encrypted leg. If not, it will fall back to unencrypted. Then you have two more options, like use encrypted or force encrypted or force unencrypted. Then finally add. And we also have a transform options in case if you wanted to modify your dialing pattern. For example, if you are dialing a PSTN phone number, like 9 followed by a number, and you wanted to append a additional digit or delete the additional digits, that can be done using the transforms. Okay, for troubleshooting dial plan. So decisions are taken by the CMS, by the call bridge component, like how to route the calls. Not every decision is printed in the logs. Okay, you might be having say 10 different rules. We won't be able to see all the rule matchings in the logs. Okay, there are some information will be logged in the rules, but not for each and every decision. Then you can enable the SIP traffic tracing. In case if you need to troubleshoot, you can enable the SIP traffic tracing to see if to see your SIP traffic, how your invites are exchanged, how you are getting the response from the far end. Is my audio visible? Audio is audible to everyone? Yes.
Now it is, Satish.
Okay, thank you. Yeah, we are done with this particular slide deck. This is your UC integration part. So we'll move on with the one more topic. I think it's a small topic. After this particular topic, we can take a quick 10 minutes or 15 minutes break. Okay, let's quickly do this. Okay, so this particular session talks about upgrading from 2.9. Okay, there are a lot of changes happened in 3.0 release. Now, a lot of new features has been introduced, and a lot of old features has been removed. So when you are planning to upgrade, there are certain things you definitely need to consider. If not, your upgrade will fail. Okay, you will end up like now having an outage when you are doing an upgrade. So I thought of like having a slide deck so that it will be beneficial for you guys to plan from 2.9 to 3.0 version. So always like when you are upgrading, we recommend you to do the step upgrade. Okay, it's something like you can't upgrade from 2.5 to 3.0 directly, or 2.7 to 3.0 directly. It has to be a step upgrade. That means if you are on 2.7, you must need to upgrade to any version on 2.8 and then any version on 2.9 and then move to the 3.0. Okay, and in 3.0 there are a lot of old features has been removed. Okay, you need to be aware that if your deployment is having any of these features are configured, and if you're planning to upgrade, you need to see an alternative way of these features. So the first feature, which is removed H323 gateway, this was we are not actually doing any enhancements to this feature since long. It was supported until 2.4 or 2.5 something. After that, we have stopped developing the H323 gateway, but this is still available in the configuration. Like even in 2.9, you can go ahead and configure the H323 gateway. This is for basically to interwork your H323 calls into SIP calls. But on 3.0 version, this configuration is completely removed. Okay, if you have H323 gateway enabled on 2.9, as soon as you upgrade to 3.0, your configuration will be removed. Okay, it will not work. X series servers. So CMS 3.0 will not support the X series servers. That means you cannot upgrade your X series servers to 3.0. They're only supported until 2.9 version. And some of the other features like load balancers, SIP edge, trunk, all these features, configuration itself is removed. Like if you have these features configured on 2.9, as soon as you upgrade to 3.0, these features will not be available. I mean, the configuration itself will be removed. And then the WebBridge 2 configuration is also removed. So in 3.0, we introduced the new web app for WebRTC calls, which is known as WebBridge 3. Okay, so all the configuration what you have for your WebRTC calls on 2.9 will be removed as soon as you upgrade to 3.0. And XMPP component is completely removed, and all the configuration related to the XMPP is removed as soon as you upgrade to 3.0. And some of the MMP commands, which are applicable on X series servers, also removed. And CMA user settings, CMA client is also depreciated. We are no longer recommending to use CMA users, CMA app on 3.0. So those user settings are also removed from 3.0 version. So this is something like this, like in the old way, you have all these configurations available, like HTTP gateway, load balancer, trunk, zip edge. But as soon as you upgrade to 3.0, you won't be getting these configurations. And if you look at your web interface, before 3.0, you have your XMPP configuration on web interface, also your web bridge settings on your web interface. But once you migrate, that will be, those configurations will be removed, and you will be simply seeing now only the time server settings and the linkage settings. Okay, so before you plan to upgrade, you must need to consider these points. Otherwise you will be having a kind of an outage during the upgrade. So make sure that you are aware the WebBridge 2 is replaced by the WebBridge 3. Okay, so no configuration will be migrated from WebBridge 2 to WebBridge 3. I mean, this is specific to your WebRTC, not for your call bridge or not for your Skype integration, something like that. It's only for the WebRTC. So whatever configuration you have for WebRTC on 2.9 will not be migrated to 3.0. You must need to manually configure WebBridge 3 again. So if you have any configuration on API, that will remain as it is, but it will not be used. You need to remove that manually from the API. So the new configuration is introduced, which is call bridge to web bridge connection, that has to be configured. So we will tell you what is this configuration in the next session. So now the WebBridge 3 is going to listen on 2 port numbers. And previously in 2.9, the WebRTC was only listening on 1 port, right? On port 443. But on WebBridge 3, we required 2 ports to be assigned on to the same interface. One for your browsers and one for your call bridges. CMM is now mandatory for your 3.0 version. Okay. If your existing deployment doesn't have CMM, first plan to install the CMM and then upgrade your CMS to 3.0. Otherwise, as soon as you upgrade to 3.0, your CMS will stop working. Okay, your CMS will become kind of unlicensed, and you will not be able to make any calls. Even though you have licenses exist on your CMS, the license files exist on CMS, it will not work until you have CMM installed. In your older deployments, in your existing deployments, if you have the capacity units as your license. So previously Cisco used to sell the licenses in capacity units, like Akano capacity units or Cisco capacity units. Those are no longer valid on 3.0. You must need to have the valid the multi-party licenses, SMP plus and PMP plus licenses. Then you can migrate. Then you can kind of upgrade. If you don't have licenses, please talk to your accounts manager and get them converted to multi-party licenses. CMS 3.0 comes with smart licensing feature. So we have an option to integrate the CMS with the smart licensing. It also supports the traditional licenses, but going forward, we might be supporting only smart licenses. So better to consider for smart licensing from now onwards. Otherwise, you have an option to use traditional licenses. For traditional licenses, your existing licenses, cms.lic file, still valid, but CMM is the one who is going to manage the licenses. You need to consider to migrate your recorder and streamer. Older versions of recorder and streamers are based on XMPP, right? So as soon as you upgrade to 3.0, your recorder and streamer will stop functioning on XMPP. Since XMPP is removed, you must need to manually configure your recorder and streamer using SIP. Okay, we would be covering this topic separately, but these are the points you need to keep in mind before you plan to upgrade. There are some more points. If you have an expressway deployments, you need to keep in mind that you are that the expressway with until 12.6 will support 3.0. Okay, and if you have if you're upgrading your expressway to 12.6.1 version, it only works with CMS 3.0. Okay, and your existing versions like 12. CMS 2.9 or 2.8 versions are no longer supported with X12.6.1. Okay. X12.6.1 works with CMS 2.9.3 versions and 2.8.4 versions. The older versions doesn't support the expressway. So there is a compatibility. You can refer this to these slides, and you can plan to upgrade your expressways accordingly. Okay, you might be upgrading your expressway alone to fix some bugs, but that may break your existing CMS deployments. So make sure that you follow the compatibility before you upgrade. And you might be knowing that we as a TAC, we only support only the two versions of CMS. That means the current version minus two versions. If the current version is 3.1 version, so that means we support 3.0 and 2.9 versions. If any issues arise with the older versions, the TAC has kind of a best effort support. We won't be able to provide you full support on the older version. So it is better you migrate to the latest versions as soon as possible. I think that's it from this particular slide deck. If you have any questions, you can feel free to ask here. We can unmute. Otherwise, you can post your questions in Q&A. So then we will break for 15 minutes. It's 12:30 now. So we can take a break of 15 minutes. Probably we can come back at 12:30. And we have a few more topics to be covered. Sharon will take over from me after the break. Vikram, can you pause the recording if it is going on?
Yeah, just 1 minute. Okay.
Okay. Thank you. My audio is clear, right? It's loud and clear. Yeah.
Yep, loud and clear. Yes.
Share my screen first. Okay. Hi, everyone. My name is Sharan. I'm part of the Telepresence Solutions Group, and we will be covering what is new in CMS 3.0 and the CMS web app component, right? The CMS WebBridge 3 CMS web app component. It's more like a continuation of where we left off in the previous slide, where we have a lot of new changes in CMS 3.0. A lot of a new set of features have come in, and a lot of options have been taken out, right? So we are going to explore what the new features are primarily. So what's new in version 3.0, right? We're first going to look at the Cisco Meeting Server web app. What is new in the CMS web app in comparison with our CMS version 2.9 and what has changed on CMS version 3.0. As you might be aware, the CMS web app was initially introduced in CMS 2.9. So there has been a lot of changes that has happened when we migrated from 2.9 to 3.0. And then we are going to move and look at the System Manager, how it has become important with the CMS version 3.0 and the smart licensing and how it all fixes together. And finally, we're going to look at this CMS deployment options that we have with the internal and the on-prem communication as well as over the expressway. Right? This is primarily to understand how the CMS web app and everything fits together in the newer deployment methods. Moving on. So the first thing is the CMS web app, right? Just so that everybody is aware, the CMS web app was initially introduced in CMS 2.9, but a lot of features like viewing the participant, a new participant, viewing, identifying whether the recording is actually running or not, all those information were not available when it initially launched with CMS 2.9. All that has changed with CMS 3.0. The CMS web app is capable of doing a lot of things which the legacy WebBridge 2 was able to do. The primary thing that has changed here is the user experience. It now aligns with what we have with WebEx, right? If a user joins on a WebEx meeting, so the same user experience is seen with the CMS web app as well. So it is more uniform throughout the different collaboration options that we have. The scalability of the WebRTC connections. The WebRTC connections are the CMS web app connections, right? It's just the WebRTC framework which the CMS web app or the WebBridge 3 component uses or leverages, right? So the scalability of these WebRTC connections have gone up. For instance, it is now at par with the CallBridge numbers. For instance, a CMS 1000 is able to take, let's say, 96 HD calls. The WebRTC is also able to take the same number of calls. When I say the same number of calls, the same number of HTML connections. So it's basically broadcasting the HTML pages for the users, right? For the loading of the web pages and everything of that sort. Then with CMS web app, you have this capability as a user to create your own space. So once you sign in to the CMS web app, you can click on the create new space, or there is a plus sign at the top left, using which you will be able to create a new space. And along with that, you have the capability to use CoSpace templates. We'll explain a little bit more on CoSpace templates, but basically what it does is, as an administrator, you can create something called a CoSpace template, and this CoSpace template will have one or more access methods, right? So access methods, there can be, let's say, one access method is for host access method, and there'll be one for your guest access method. And your host access method is how the hosts of that particular meeting would join, so that they have all the features like starting a recording or stopping a recording, muting other participants, unmuting other participants, things like that, right? For a guest access method is where you would just join, you would not be able to do these admin related tasks like unmuting, muting, perhaps not being able to start or stop the recording, etc. Right? So you can create these different access methods. You can associate them or assign it to this CoSpace template, and you can allocate this CoSpace template to a user. And when that particular user creates a new space, that user has the ability to select this template. So if there is more than one template which is allocated for this user, the user can choose from that particular template and create the. And when they create that new particular space, anybody who joins that meeting will have these different options. So depending on how you want the other users to join this particular meeting, you can share the host access method, or you can give the guest access method. Why this is important is because it reduces the administration task. So once you create a particular template and you allocate it for a user, and that's done to the user so that they can create their own spaces whenever it is required. Right? It's not just directly you need to allocate these CoSpace templates to a user. It can also be done during an LDAP sync. The other thing that come up with CMS 3.0 is branding. So this was not available with CMS web app on 2.9. With 3.0, you have the capability of branding, and we'll see what all can be branded, right? And as always, the meeting controls, we now have all the start recording, stop recording, layout changes, all those meeting controls have been added now. Okay. This is just to give you an idea on how it actually looks when you sign in. This box here in the back is actually how it looks when you actually sign in. You will see this creative space, or you will see a plus icon here to add or create a new space. You can always click on any of these meeting spaces that you have already created and click on join. And if you click on join, you will get some interface like this, which actually matches with what you have for your WebEx, and you can click on join meeting and you should be able to connect to that meeting. You also have this mute audio video options as well. And yeah, you can always change the way you join. Like let's say you want to join from a video device, that is also possible. You can click on this drop down and change the way you join. Okay, so this is just a comparison chart between what all features were available in CMS 2.9 for the web app as well as for the CMS 3.0 web app, right? It's basically a comparison table that will give you an idea on what all new has been actually added, right? For instance, adding or dropping a participant was not available in the CMS web app in 2.9, but that has been introduced in 3.0. So you can see a list of things that has been actually added. For instance, initiating a recording or the recording indicator, as in if the recording is already running, you have that indication that the recording is actually running. Right? Muting capabilities, branding capabilities, all of them have been added. Localization is something that has been added on 3.1. It is not available on 3.0. So it's a 3.0 minor release, which means it's on 3.1. Right? And in-meeting chat is on the roadmap. It is not deployed yet. So hopefully it should come sometime soon. Now this is another comparison on the UI actually looks. So if we look at the bottom one here, this is the new WebBridge 3. So it is the WebBridge 3, which is actually giving you the CMS web app, right? The WebBridge 2 is your legacy WebBridge, which we have all been using up until 2.9, right? WebBridge 2 was available in 2.9 as well, till 2.9, right? From 3.0, you do not have WebBridge 2. From So 2.9 was your version where you could have had both WebBridge 2, that is your legacy WebBridge, as well as your new WebBridge, that is your CMS web app. And if you look at the UI, if you just open your browser and type in your join URL and press enter, the page would load something like this, the one on the center, right? The web app join, where you have the join meeting option as well as the sign in option. So if you click on the join meeting option, you'll be navigated to something like this on the left side here, where you will be prompted to enter the meeting ID, the passcode, and then you can click on join meeting, right? If you click on sign in, you're basically being asked to enter your user ID, right? Something like user ID @domain, your based password, and you click on sign in. Right? The behavior is somewhat similar, but the UI has actually changed so that it matches with, it aligns more with the WebEx UI experience. Once you sign in, right, this is how the page would look. This is somewhat deeper look into how the UI would look. Once you sign in, right, you will have this sort of page, the one which you're seeing at the back, right? You will see all the spaces that you would have created, and you will see some recent spaces that you are available to join here. And if you click on this plus sign here, it'll give you a pop-up, and you can basically type in the space name, the new space name that you want to create. And this is as 3 templates allocated. So basically he or she can select one of the templates and click on create, right? So the dependency, as in what all access methods or what are the different, let's say the call leg profiles or the call profiles which are associated with this access methods or the CoSpace templates, that depends on the configuration of each of these templates, which is managed by the administrator. So as a user, you only can select the particular template, and you should be aware, okay, this is what this CoSpace template would do. If I select this template, you have a host and guest kind of access, right? So they should be aware what is there. And this description here hopefully will help the user understand what they're going to get when they create a particular space using this template. And when you click on a particular meeting, you have that option to actually join the meeting as well. Right, this is the option that will actually pop up when you try to join the meeting. Right? The other thing that I want to point out is the star here in the screenshots. It does not mean they are part of the UI. It is just to show that this is something new. All these stars are new. It is not part of the UI. Okay? Just to confirm that part. Now the meeting options, right? There are a lot of meeting options which were missing on 2.9, which has been included in 3.0 web app. So you have the layout control. You can change the layout. You can click this icon here and basically select the layout you wish to use. You have the recording control, streaming control, audio mute and unmute, right? Same goes with video. You also have the meeting lock and unlock. You can see the participant list and individually mute them if required, mute and unmute them if required. You also have this option to make a particular participant as important, which means even if that person is not the recent speaker, that person's video would still appear on the screen, right? If the appropriate layout is selected, that person's video should still appear on the screen if you make that person important. You have the ability to add participant. You can basically type in a SIP URI and make out a call from this, right? And the major other additional part here is the diagnostics. The diagnostics has always been there, but it's a better kind of click on this. You get a pop-up and you can enter some information as in what problem you are facing and click on send and create. So basically this sends out the diagnostic information to the server so that it helps with troubleshooting for the administrator. We'll move on. Okay, now looking at branding, right? For CMS 3.0, web app branding is possible. This was not available in CMS 2.9 when the CMS web app initially came. Right? So you can actually brand a lot of things here. To simplify, the only thing that you cannot brand or change is your Cisco logo here. As simple as that. Pretty much everything else here can be changed. For example, the browser tab here, the logo can be changed, brand title lines and the tagline, everything can be changed, and even background image. Right? All these information can be changed. I mean, all this data can be changed here. The only thing that you cannot change is the Cisco logo. Right? Now, done with the new changes or the features that have been added on CMS Web App 3.0, we're going to look at the changes or the new features available on Cisco Meeting Management 3.0. Okay, so based on whatever information that you've already got, you might be already aware that CMM is mandatory from CMS version 3.0. Right? So CMM 3.0 and CMS 3.0 should work together from once you upgrade to the version 3.0. So this is because the Cisco Meeting Management is responsible for managing your licenses from versions CMS version 3.0 and above. So if you do not have a Cisco Meeting Manager, then your CMS servers, which is running 3.0 and above, cannot be licensed. And irrespective of whether you use a traditional licensing or a smart licensing, you still need to have Meeting Management 3.0. Right? It also helps with license usage report, where in the CMM, you have this nice UI where it will show you the license usage, whether you have overage, meaning if you are using more than what you have actually bought, basically it gives you an idea on how much licenses you are using. And it gives you an option to download a report for up to 90 days. This is how the CMM smart licensing enforcement has changed with the older versions and when it has arrived on CMS 3.0. So for the different deployment scenarios which are available once you go to CMM 3.0 are here. If it is an existing customer and if you are upgrading to, let's say, CMS 3.0 from an older version, the CMM is mandatory. That is going to stay mandatory, but the smart licensing is optional. Even though smart licensing is optional, it is possible that the idea is to go to smart licensing based licensing method and move away from the traditional method. So it's best to consider moving to smart licensing, but it is not mandatory at the moment when you move, basically upgrade from when you upgrade from 2.9 to 3.0. For any new customers who are being deployed into CMS 3.0 and CMM 3.0, CMM is always mandatory as explained, and with the newer deployments, smart licensing is also mandatory. So when you deploy a new customer, let's say to 3.0 version, CMM is mandatory and smart licensing is mandatory. Right? You can also deploy CMM in licensing only mode, which means a particular CMM, if you set it on licensing only mode, that CMM is not going to manage the meetings for that particular CMS cluster. It's not going to look at the CDR or the different meetings which is happening on the CMS cluster. Rather, it will just manage the licensing for that CMS cluster. This is required when you have, let's say, a large CMS cluster. For instance, when you have 9 or more call bridge nodes running together. Right? In such scenarios, you might need to keep a separate CMM, a dedicated CMM for managing the licensing, right? And a separate CMM. All right. So just to give you an idea on how the licensing is validated, or when you initially deploy, let's say, CMS and CMM 3.0 for a new customer, right? How the licensing is validated and how you can get your CMS licensed or your CMM licensed, right? So when you initially deploy it, obviously this CMM or the CMS will not be licensed, right? It is obviously not registered to any CSSM, smart software manager or anything of that sort, right? So what you can ideally do is when you first initiate this and you connect your CMS and CMM, once you connect the CMM and the CMS, you can actually initiate a trial mode. This gives you a clock of 90 days where you can use where you can use CMS, right? You can use CMS for 90 days without any problems. You should be able to use all the features there. So this is basically where you are expected to license your CMM, right? Sorry, you license your CMS, right? You're basically expected to put some license on your smart software manager on the cloud, and you are expected to connect your CMM to that CSSN so that your CMS gets licensed, right? For instance, if you were not able to license it within the first 90 days and the trial mode or the trial period expires, a license alarm will be generated from days between 90 to 180. Whenever a participant joins a meeting, they would see a text saying that the CMS server is not compliant or it's using too much licenses. And also they would hear an audio prompt saying that the server is not in compliance. Right? That's what would happen. And this audio prompt and the text prompt will go away after 30 seconds. So that is what happens for the first 90 to 1. Have the same behavior. The only difference is that the text on the screen and the prompt will be there throughout the meeting, right? So for every participant who joins the meeting, they will see that text saying that, okay, this is not in compliance, and they would keep hearing the prompt throughout the meeting. Now, your way to fix this is basically to add license to your smart account and link it or register it with your CMM, so that the CMM basically tells the CMS that, hey, you are registered and you are compliant, right? Your licenses are valid. Errors and the text messages and everything goes away. All right, so we have been discussing, we briefly talked about the different deployments for CMM, right? So in most scenarios, you can have the CMM doing both licensing as well as meeting management. Right? In most scenarios where you have small to medium customers, let's say anything less than 8 call bridge clusters, for example, you should be able to use CMM licensing and meeting management from the same CMM server. Okay, there are different criteria. So the number of nodes is just one of the things. The other one is the number of meetings per week. Right? If you have a large number of meetings per week, then ideally it's best to split using the CMM for licensing and meeting management. So there are different criteria that go around deciding which deployment to use. This is something that we will explore when we cover the core CMM tomorrow. Now, so the other option is to use CMM licensing without meeting management, right? So this is a new option that has come with CMM 3.0. So if you go to settings and that settings server option, you can basically click on that particular server and you can uncheck this, right? Use meeting management to manage meetings on these clusters. So if you uncheck this, you are basically telling the CMM that it does not have to manage the meetings for this cluster, right? For this cluster means whatever CMS servers is added under this cluster, it is not going to manage the meetings. So it will only be responsible for licensing, provided you have enabled the licensing part on this CMM. If you do not have meeting management and the licensing part, the CMM is not playing much of a role here, right? So it's either the meeting management or the licensing or both. Okay? So you have this new option to make CMM just to licensing and disable the meeting management. Okay. So this is an example where you have two CMMs, and one of the CMM is taking care of your meeting management. Right? All these green lines here represent the meeting management communication, let's say APIs and HTTPS based communication, which is happening here. So this is your CMM, which is handling your meeting management. Right? So let's say a user joins and all that information will be visible for the CMM dedicated for license, the one here. So this orange line that you see here is basically license information, which is being connected with the CMS and also with the CSSM, right? The Smart Software Manager. Okay, and like I said, there are different criteria on how you decide whether to split them up or not. One of the examples is if you have more than 10,000 meetings per week, it is best to split them up. Or if you have, let's say, 9+ call bridge nodes, it's best to split licensing and meeting management. So if you have 2 or 3 CMS2 case, it's best to split them again, right? So you have a dedicated CMM for meeting management and a dedicated CMM for license management. Okay, so we have been saying that we need to connect the CMM to the CSSM, the Smart Software Manager, right? So how do we do that? The first thing is you need to log into the Cisco software portal, and you need to connect to virtual account on which you have added your CMS licenses. You connect to the virtual account where you have the CMS licenses added, and then you can go to inventory and you can create a token. You can basically generate a new token, and then you can copy this token from the CSSM, from this Smart Software Manager portal. You can copy that token, and now you can go and log into CMM and go to settings, licensing, and you can register it here. So before registering, obviously you should be using smart licensing. Otherwise, this token makes no sense in being generated or connecting it here. So we set the licensing mode as smart licensing here inside settings, licensing, and licensing mode as smart licensing. Then you can click on register. It should give you this pop-up where you can paste the token that you just generated from your CSSM and click on register, right? So once it is registered, it should be able to pull the information from the CSSM and communicate with the CMS so that the CMS is aware that it is licensed, right? One additional thing that you need to do on the CMM is to basically set the allocation, right? So once the CMM comes up, once you connect with the CSSM, you basically need to tell how much is allocated for, let's say, for the SMP, shared multi-party plus license, and the personal multi-party plus license. Right? So you can click on this edit option. You can set the allocated number and click on save. Sorry. Once you do that, you should see the CMS and CMM communicating and sharing information regarding this licensing, and the CMS should get licensed after this. Right? And on the overview page, you can just get a small glimpse of customization is also licensed. Right? Your meetings is your SMPs and your PMPs. Now, we have covered what is new in CMM. We're just going to look at the deployment overviews in CMS 3.0. Right? The primary part that we are going to look at here is the scale. Right? We are already aware of the different deployment methods where we have on-prem, we have users coming over the internet, we have the proxy kind of setup. Right? This is just to identify the scale or the number of users which are allowed to connect over, let's say, on-prem or over the expressways. Okay? The first one is the internal deployment. So for anybody new to the WebRTC, you have this browser here, which is, let's say, connected on the internal network of a corporate network, and you have the Cisco meeting server also running on the corporate network. Everything is on the internal network here. So if you have a browser which is going to do WebRTC based conferencing, the browser is going to connect to the CMS WebBridge 3 because it's 3.0 and we are running WebBridge 3. The browser is going to connect to CMS WebBridge 3 for HTTPS communication to load, let's say, the web page and everything, which is where you get the join, sign in options and all those options. And the web browser, once the call is completely negotiated, it will send or receive media directly from the call bridge. So the browser is going to send media to the CMS call bridge, and the CMS call bridge will send media back to the browser directly. Right? So the major thing that we need to look at in this particular slide is the scale, right? So with CMS 3.0 and with the usage of CMS WebBridge 3, the scale has increased, which means the WebBridge 3 scale and the CallBridge scale are at par, right? For instance, if you have a CMS 1000, which is running HD, let's say 720p with 30 frames, you can have 96 participants connecting for WebBridge, right, on a CMS 1000. And if it is a CMS 2000, you can have 700. And depending on the quality, let's say for full HD, it's going to be 48 and 350. Okay, and a quick note, it does not mean, let's say, if it is for CMS 2000 on running 720p 30 frames, it does not mean 700 plus 700. It just means 700 users, but it is able to take CallBridge and WebBridge connections here with 700 participants. Right? So this is the second deployment where you have users connecting over the internet. So this means this user on the right side is not capable of directly communicating with the Cisco meeting server on the internal network. Right? So there has to be some way this browser is able to send audio, video, and the HTTPS communication through the internet, finally reaching the Cisco meeting server, CallBridge, or the WebBridge 3. Right? So we can actually use an expressway CE pair to traverse this particular or proxy this particular audio video communication as well as the HTTPS communication. So the browser would actually send the HTTPS communication to expressway E, traversing to expressway C, and C would proxy it to the WebBridge 3 on the CMS server. And for audio video, ideally what would happen is the audio video will be sent to expressway E, which would act as a turn server, and relaying the media to expressway E would relay the media to the call bridge. Right? The expressway C is generally not involved in that media flow. Okay. So the scale, once again, the focus here is on the scale. The official tested numbers for the calls coming over the expressway is 200 for anything other than full HD. Right? If you're using a CE 1200 or a large OA on the expressway E servers, you can have up to 200 participants coming over the internet for a single expressway EC pair. So for one CE pair, you can have up to 200 participants connecting. If you're using full HD, it means it will become 150 participants. And the other note here is that the scale can be increased by clustering expressway E and Cs, and it can go up to 4 node clusters. Expressway C and E can cluster up to 6 nodes, but the scale will only go up to 4 nodes. The other 2 are basically for failovers. So if you have, let's say, a 6 node cluster for expressway C and E, the number of calls that it can take is basically 800 calls. Right? If you're using full HD, it might be 600 calls. So depending on the resolution, it might slightly change, but ideally you should be able to take 800 calls here. Okay. So the third deployment is again what we just explained. It's just that you have multiple expressway C and E's, right? So you have this expressway C here clustered, and you have this expressway E here clustered, right? So this means in this particular example, you should be able to take 400 calls, right? Because for one pair, it should be able to take 200, which means with the second pair here, you should be able to take 400 calls, right? And yes, you are the external GeoDNS to connect through to the different expressway clusters, since it might be deployed in different regions in the world. So you are free to use external GeoDNS, and which works perfectly well with the Expressway ENC deployment for web proxy. Okay. Okay. Now with CMS 3.0, it's a small note with respect to recorder and streamer. This is something which was already covered, but just to reiterate, the CMS recorder and streamer on versions 2.x up until 2.9 have been reliant on something called the XMPP component, and they have been using the XMPP protocol. So the recorder or a streamer would ideally connect to the call bridge as an XMPP client. Right. This was how it was happening. And there was always an XMPP authentication, the SSL-based authentication that used to happen. So there was always a dependency with the XMPP in up until version 2.9 for streaming and recording. But this has changed now with the introduction of CMS 3.0. With CMS 3.0, the streamer and recorder are both SIP-based solutions. So there is no requirement to have XMPP in your deployment. And this means with CMS 3.0, the XMPP component has been completely removed. It was the WebBridge 2 streamer and the recorder in the older versions, which was actually utilizing the XMPP. So since all these solutions have been migrated to use SIP or HTTPS otherwise, the XMPP component has been completely removed and is not used by any component from 3.0. And once again, there is no automatic migration for your streamer or recorder. So if you had a streamer or recorder in 2.9, you will have to manually make some configuration changes so that it applies for the newer SIP-based configuration. The feature set still remains the same with the addition of some of new features as well. For example, with the new SIP-based recorder, have the capability to change the layout as well for the recordings. And if you think about streaming, you can have full HD based streaming, which is not available before. So all these new functionality has been added, and some of the older dependency with the XMPP protocol, which was not so great, has been removed, and it's all become SIP based. Okay, once again, some of the things which have been removed and you should really consider before upgrading to 3.0. CMA clients have been removed, so you are recommended to use, let's say, Jabber as an alternative. WebBridge 2 has been removed, which is your older WebRTC based clients and connection. Your WebBridge 2 component is not even available on CMS 3.0. So you're expected to use the WebBridge 3 component, which is the new web app. XMPP has been removed. So there was a lot of dependency with XMPP with multiple components in the older CMS, which was creating issues with scale and everything, which has been removed now. And all the other components are not dependent on the XMPP protocol anymore. H323 has been removed, and you're expected to use Expressway for interop with H323 and SIP. Yeah, XMPP based recording and streamer has been changed. SIP-based recorder and streamer. The feature set is still the same with some additional features again. X series is not supported on CMS 3.0 and is going end of life. So you are expected to move on to different hardwares, let's say CMS 1K or 2K, depending on your requirement. Okay, some of the resources that you can use, like FAQs and release notes, which might come in handy when you try to migrate to the newer resource, to the newer version. Okay, so before we go into the Cisco meeting server web app details, right, where we will try to understand how the component works, I just wanted to give you a small heads up or some information on the features that are available on CMS 3.1. So we have something called video enable, disable, and audio mute, unmute modes. What this actually does is, in older versions, up until version 3.0, if you mute an active control-based endpoint, you are unable to unmute that device. You need somebody locally to unmute that device. So that endpoint will need to be manually unmuted, either from the GUI or manually on the, let's say, on the touch panel or something of that sort. You'll have to manually unmute it. This is not the case. So this is not the case from CMS 3.1. So with CMS 3.1, you have that additional capability to unmute that device as well. It is not implemented without any changes. You need to do some sort of configuration so that you can actually apply this. The ice tracing has been improved. Initially, the ice tracing used to print a lot of information and it was not very easy to track certain problems, but that has been improved and it actually prints a lot of useful information now. And there has been improvements in packet capture where you are now allowed to do packet captures, let's say from more than one interface or from all the interfaces in the CMS. You also have the ability to pass in different filters for the packet captures. So if you pass in a particular IP address as a filter, the packet capture module will only collect packets for that particular filter, whatever you have passed to the system. Then you also have RTMPS streaming. We only had RTMP streaming up until version 3.0. Now we have RTMP over TLS. You have secure RTMP basically. Then you also have this new edge solution. So this is for those users where you have a lot of users connecting over the internet, right? So as you have seen before, our expressways can scale up to 800 calls. If you have one full cluster, it can go up to 800 calls if you're using anything less than full HD, right? But so for customers who have a larger deployment, let's say 2000 users need to connect over the internet to the CMS for WebRTC. So we have this new solution where you would have CMS Edge, which will have your Edge web app and your Edge turn services, which will actually proxy the information to the core servers. Right. Then again, once again, on the CMS web app, there has been few modifications. An email template has been allocated. And you also have the interface localization as mentioned during the beginning of the session. The localization was supposed to be released with 3.1, which has happened. And the major other change is that you have single sign-on now for your CMS web app. Right? So for when you sign into the CMS web app, you have SSO. This does not mean you have SSO for your administrator login to your CMS web admin page or to the CMM web admin page. It's just for your CMS web app. And if you want, you can always go to the release notes. You will get more details on all of them. And there are some of other minor features as well, which is actually released along with this. Okay. Excuse me. Okay. Now that we have covered what is new with CMS 3.0, we're going to now look at the Cisco Meeting Server web app. Right? We're going to try and understand how the CMS web app actually works, how it is different from the legacy CMS Fabric 2 solution, and try to understand how we can configure it. Right? Now, some of the information is already covered at the beginning, but just to reiterate, the user experience is matching with WebEx now. Then you have template provisioning. As explained, you can create a template. You can allocate it for a user, and that user, when he or she creates a space, whatever template configuration was allocated will get inherited to that particular host space. Right? So the use of space creation and allocation is much more simpler, and the level of administrative tasks required is also reduced here. Right? The most important thing here is that WebRich 3 does not require XMPP. So your CMS web app runs on WebRich 3, and your WebRich 3 is not dependent on XMPP protocol. So with 3.0, with no XMPP, WebRich 3 will work just fine. Right? Now, CMS web app was initially available from CMS 2.9, and it is there from on all the newer versions. So CMS 2.9 was one version where you could have had both the older WebRich 2 as well as the WebRich 3, right? But in CMS 2.9 also, the older WebRich 2 still need to use XMPP. At the same time, the newer WebRich 3 did not have to use XMPP. Now let's look at the overview of the CMS web app, right? To start off, WebRich 3 is not supported on Akeno X series. So if you wish to use WebRich 3, you need to run it on CMS 1K, 2K, or a virtualized server. Okay. Now, before I explain or go through the second point here, I just want to share some small concept so that this point makes more sense. Okay. So irrespective of whether we were using the old WebRich 2 solution or the new WebRich 3 solution, we always had to configure the call bridge to connect to the WebRich. Okay, whether it was WebBridge 2 or WebBridge 3, you need to tell the call bridge to connect to the WebBridge. So that is how call bridge would connect to the WebBridge, and they would exchange information. So before, in the older versions, CallBridge used to connect to WebBridge using something called just the plain old HTTPS protocol, and they would communicate with each other, right? But on the newer WebBridge 3, instead of HTTPS, we use something called C2W. It's a custom protocol called CallBridge to WebBridge protocol. So this means the call bridge is not anymore connecting to the same HTTPS communication on the WebBridge. It is a totally different communication, totally different port on the WebBridge 3, and it's a different protocol. It is HTTPS based, but it is a totally custom protocol, which we are calling it C2W, call bridge to WebBridge protocol. Okay. Yeah, WebBridge 2 and WebBridge 3 can be hosted on the same CMS. This is something that we are already aware of. And WebBridge 2 is completely removed on CMS 3.0. So what this means is if you have a WebBridge 2 running up until 2.9, it is fine. But when you upgrade, you have to deploy WebBridge 3, right? So there needs to be some sort of manual configuration that you need to do. There is no automatic migration from WebBridge 2 to WebBridge 3. Okay, so this is the flow comparison, right? Just so that you understand how the WebBridge 2 and the WebBridge 3 are working, right? Before I go into the details, let me try and explain what are the different components that you see here. The first thing on this left big box here, you have the browser, which is, let's say, a user trying to communicate or connect with one of the meetings in the CMS. Then you have the bigger box here, which is the Cisco meeting server running CallBridge component. It is running WebBridge 2 component, and is running XMPP server. Right. So here the browser is connecting with the WebBridge for HTTPS based communication. Right. This is how it will load the HTML pages and everything from the WebBridge. Right. So and the browser will connect to the CallBridge directly for your media. And it's going to send and receive media through this channel here. Now, there is an initial communication which the call bridge will do to WebBridge, right? There is always a connection, not just the initial part, but obviously initially the call bridge initiates that connection, but even after that, there is throughout communication which is happening between call bridge and WebBridge. So this communication also happens on the same HTTPS port on which the browsers also connect, right? So basically, there is an overhead for the WebBridge 2 component where it needs to listen on the same port for two different types of communication. Right. On top of that, you obviously have a lot of browsers communicating with the same port, right? So a specific browser type of communication connects to the same port, as well as the call bridge based communication connects on the same port. So there was some sort of was creating problems. On top of that, there was an additional component, the XMPP server component, which was involved in the authentication. Irrespective of whether the user was trying to sign in or join a meeting, there was always some sort of authentication that happened, and that authentication involved the XMPP server or that SASL authentication. Okay. Now move on. Solution. The difference here is there is no XMPP server component involved, right? It has been completely removed because we do not need XMPP server component for authentication. Okay, it uses something called JWT, which is JSON web-based token for authentication, for two-stage authentication. Now, the other change is that the call bridge is not communicating on the HTTPS port on which the browsers communicate. So it's a totally different link here, and it is connecting to a different port on the WebBridge 3, and that is the C2W port on the WebBridge 3. Okay, and it uses a C2W protocol communication between the call bridge and the WebBridge 3. The media communication and the HTTPS based communication still remain the same. So from the browser side, it's pretty much the same. It's just that the architecture within the CMS, which has actually changed on how the WebRTC framework is implemented. Right. Okay. Now we are moving on to the configuration. Some of them which have been covered, but just hopefully will give you more idea on this. To start off, for CMS web app, the most important thing that you should be aware while deploying CMS web app is the certificate part, right? For CMS web app, you need to deploy or you need to use full chain certificates. So in the CMS web app, you ideally have two components. We already know this. We have this HTTPS based communication, which happens with browser, and you have a C2W based communication, which happens with call bridge. So obviously you need two set of certificates for sure, right? For this communication with the browser, you need a pair of certificate and you need a pair of certificate to communicate with the call bridge. You can use the same set of certificate for both these communications, but you need to allocate them separately. You still need to configure them. Whether you use the same certificate or different certificates, you still need to configure them. And the major fact here is you need to use full chain certificates. So what is a full chain certificate? It means it is the complete chain of certificates, starting with the entity certificate or the server certificate and finishing with the root CA which signed it. For example, if you have a server certificate and it is signed by an intermediate server certificate, the entity certificate will go first in the bundle. It will be followed by your intermediate server certificate, which signed the entity server certificate. And whatever root CA that signed this intermediate server certificate will follow the intermediate server certificate. So it'll be like entity server certificate, followed by intermediate root certificate, and finally the root CA certificate. And all of them will be bundled into a single file, forming the full chain certificate. You can create this, usually you have this option to download full chain certificate from the CAs, or you can always create it with the notepad as well. You can basically copy them in a particular order and you should be able to get that done. The method on how you do it is actually there on the certificate guidelines guide. Okay, and you obviously need certain SAN and CN entries to match how you actually connect to the web bridge, right? So depending on, let's say the user joins the web bridge using a FQDN, right? join.cisco.com or something of that sort. That FQDN should be present as a SAN or CN in the web bridge component. Same thing for your C2W certificate, the way the call bridge will connect to the web bridge. Even for that information, it's best to have that information on the web bridge 3 certificate for the C2W component. Okay. So specifically now looking at the configuration, first, obviously you need to have this component disabled, right? So that you can apply the different configuration. So if for some reason it is running, you need to disable it by running web bridge 3 disable. These two configuration are for your HTTPS based communication, right? So this is basically to set your communication with your browsers or your browser clients, right? Whoever wants to join the meeting. So the first one here is your web bridge 3 HTTPS listen. It's basically telling your web bridge to listen on a particular interface and a particular port. Usually we will set this to 443 because we wouldn't want the users to basically type a particular port to connect for a conference. We would just want them to type in the join URL and press enter. We wouldn't want them to put in a port, right? So if you do not put a port, it's 443 by default for a browser. Right? So generally we set this to a certain interface, let's say A, and port as 443. Then you set up the certificates for the same component. For the web bridge 3 HTTPS, you set up the certificates here, and this is the key exchanged with the browser. When somebody opens the browser and tries to communicate with the web bridge 3, the certificate exchange will be this one. So if you have certain policies where you need secure communication, it would be best to use a CA signed certificate here, so that you do not see any pop-up or anything of that sort when a client connects to it. Right? The first part here is the private key, and the second part is your full chain certificate. So you are expected to use a full chain certificate when you set up the component. Now the WebBridge 3 is ready to listen for browser-based communication, right? For the HTTPS communication. Now we need to make it ready to listen for C2W communication from the call bridge. So that is taken care by these two commands first of all. Right? The first thing is to do a WebBridge 3 C2W listen, and you give an interface and a port. Right? So it will be on this particular interface and port that you expect your call bridge to connect and talk C2W protocol. Right? And the second line here is to set the certificate for the C2W communication. So when the WebBridge 3 communicates with the call bridge, the certificate exchange will be this one here. In our example, we are actually using the same certificate for C2W as well as for your HTTPS communication. But that is not a requirement. You can always use a separate certificate as well. In fact, it'd be better if you use a separate certificate so that it's more secure, right? And this certificate does not necessarily have to be a CA signed or a public CA signed, right? Because it is just internal communication and does not require to be public CA signed. Now, once this certificate is set, the other thing is to make your web bridge trust your call bridge, right? So there is obviously a TLS handshake which happens, and the web bridge 3 should trust your call bridge server. Right? So for that, you can actually append the root CA which signed the call bridge server certificate to the C2W trust store. So we are basically saying web bridge 3 C2W trust store, append this certificate. So if there is a certificate which is signed by this root CA, we will trust it. Okay. You also have the option to actually do certificate pinning, where instead of a CA, you can actually put in the server certificate bundle as well. Right? If you have multiple call bridges, you can also do certificate pinning as well from CMS 3.0. And finally, you can enable the web bridge 3 component. You can type in web bridge 3 enable, and the component should C2W is successful and the component is enabled. You can also type in web bridge 3 status and it should show success. So this completes the web bridge 3 side of configurations. We still need to prepare our call bridge so that it can accept these connections, right? Or it can make these connections, to be more correct. Now, the first thing is in the call bridge, you need to, on the call bridge, you need to trust the web bridge 3 certificate, right? So what, just like how we trusted the call bridge certificate on the web bridge 3, the same way you have to trust the web bridge 3 certificate on the call bridge, right? So you have this new command which has been added from CMS 2.9, call bridge trust. For C2W, you will trust this particular root CA, which means any certificate which is signed by this root CA, we will trust it and the communication will go through. The TLS handshake will be successful. Right? And you also need to restart the call bridge so that the changes take effect. Now, the one last configuration that you need to do is to tell the call bridge where the web bridge is. Right? Even though they are running on the same server, let's say, you still need to tell the call bridge where the web bridge component is. And you basically need to feed it the IP address or the FQDN of the web bridge 3, so that the call bridge will in connection to that particular web bridge 3. Right? So when you create this communication, it is very important to note that you always use or prefix C2W at the beginning. Right? Because we do not want the call bridge to do HTTPS based communication to web bridge 3. We want it to use C2W based communication to web bridge 3. Right? So how do we do it? We can go to the CMS API page. You can go to API v1 and web bridges, and you can basically type in the URL here. So C2W : FQDN of your web bridge 3 server. Assuming it is on the same or different server, you can type in the web bridge 3 FQDN followed by : port number. So this port number is the port number that you assigned for web bridge 3 for the C2W listening, right? So there we actually did a web bridge 3 C2W listen interface and port here, right? So we are expected to put this same port number because our web bridge 3 is listening on this particular port number for C2W communication. So you have to feed the port number information to the call bridge so that it connects appropriately. So this line basically tells the call bridge, go talk to cms3.newworld.com using the protocol C2W on the port 9999. Right? With this, your configuration for your CMS web app is done. It should be able to come up once you do this. Okay. We're just gonna quickly look at some of the troubleshooting steps as well for CMS web app, right? How you can actually navigate or actually try to identify what is happening wrong while you join a meeting or when you sign into a meeting or when you sign into your profile, right? The most common thing or the easiest thing that you can actually do is, especially if it's a new deployment, what I would recommend is to use a syslog follow, right? So you can have a user attempting to log in or let's say sign in or join meeting, and you can log into the CLI of the CMS and type in syslog follow, and you should see all these logging information there, and you can ask the user to sign in. or join a meeting, right? And you should see information like guest login request and call ID lookup, and you should be able to track what exactly is happening. Right? This is from a successful connection. So this is for a join meeting option, not a sign in, right? It is basically creating a guest ID, and this guest ID will get authenticated. This is not detailed, of course, it's just an info, but you still will get an idea on where exactly it is failing. And if required, you can always set up detailed tracing for the web bridge component, and you can do syslog follow and get more details on it. Right? Now, let's say you still did not get enough information here on the syslog. Right? There's an added option where you can actually put in some flag here. Right? When you try to join a meeting, and let's say it's failing, right? And if you want additional information to be displayed on the screen or on the syslog or on the logs, you can basically add a question mark, trace is equal to true, right? So when this particular user will try to join or sign in, it is going to set this flag as true, which means it will print a lot of additional information when the user joins the meeting or signs in. So it might give you some more idea on what exactly is failing. Right? This is only for troubleshooting. You're not expected to set this trace level to true for random users, right? This should not be passed on as a join URL to all the users who try to join, right? You should not be passing this. This is only for troubleshooting. Let's say for one user, if it doesn't work, you can try this out. Okay, with the new CMS web app, one of the common issues that we see is the page will load when you let's say when you type in something like this, the join URL. I'm using an IP address here, but you can always use a FQDN, which will resolve to certain IP address, right? Which will be your CMS WebBridge 3. So when you type in something like this, ideally what we would expect to see is this join meeting and sign in option, right? With this, provided it's not branded, right? Otherwise it will look exactly like this, right? Now, there are scenarios where you will see something like this. The system is currently unavailable. Please try again. So what you can ideally do here is do a syslog follow, right? Initiate a syslog follow on the CMS server, and you can basically try to connect to the join URL again, and you can see what is happening. Right? So some small hints on what you can look at, right? This host colon server means your call bridge. So if this host colon server is saying something, it means your call bridge is saying something, right? So in this example, the call bridge is basically saying it's an error, and the C2W peer. So the C2W peer for the call bridge is your WebBridge 3, right? So it's saying that the C2W peer, the WebBridge 3, failed with TLS handshake, and the error is IP address mismatch. Right. So as soon as you see this TLS handshake, it's you can always get the packet captures as well, so that it will give you more idea. But with this sort of logging, it's pretty clear that there was some sort of TLS handshake which failed, and it is because we were not able to match a particular IP address. Right. So this ideally means our call bridge was configured to connect to the web bridge using an IP address. So you can see here it was configured to connect to the web bridge using an IP address. The C2W part and the port are all correct. Okay, it's just the problem with the IP address. And the IP address itself does not have any problem. But the problem is when it connects to this web bridge and it does the TLS handshake, it will validate that certificate which the WebBridge 3 provides. So during validation, we expect to see this particular IP address in the SAN entry of the WebBridge server certificate. And if that is not there, it will say IP address mismatch, right? Because we are connecting with an IP address, right? For the second example, if you say cms2.darmckin.local, right? So if we are connecting to this particular web bridge, and the web bridge server, when it provides its certificate to call bridge for validation, it should have this particular FQDN in the SAN entry. If it is not there, it's going to throw another error saying that TLS handshake, right? SAN entry mismatch or something of that sort will get printed over here. Right? And if the TLS handshake fails, obviously your meeting CMS web app is not going to come up. Okay, this is just another scenario where you have a similar sort of problem, right? Let's say the user opens the URI and it shows up something similar, right? But this time the error is slightly different. Once again, it is from the host server, which means from the call bridge, and it's saying complaining something about the web bridge. The C2W peer for the call bridge is your web bridge. right? Again, it's the TLS handshake, and it's saying self-signed certificate. Basically, this is indicating some sort of trust problem between the call bridge and the web bridge certificate. Perhaps it is that we are not able to trust the particular certificate which the web bridge prompted or the web bridge sent to the call bridge, right? So you might want to look at what you have configured in your call bridge trust store here, right? You might need to validate what is the call bridge trust store that you have configured and compare it with what is configured as the C2W certificate for your web bridge, right? So this is the certificate which the web bridge will send to call bridge, and will this certificate be validated correctly with using this particular trust store? Right, so you might need to do some comparison, and you might be able to look into the certificate using PKI inspect and should be able to see what is happening or what is going wrong, right? And especially for TLS handshake related issues, it might be a good idea to get your packet captures as well, because it obviously is going to give you more information, right? Now, one more scenario that I want to show here, primarily because it's not the host colon server anymore here. Right? Let's say it's the same sort of problem, but this time it is not the call bridge which is actually complaining. Instead, this client underscore backend is actually your web bridge 3. Okay, the web bridge 3 is saying there is an error, and it's saying that it's complaining about the C2W peer. So here the C2W peer is your call bridge, right? For a web bridge, the C2W peer is your call bridge. And just so that everybody is aware, when I say web bridge, I'm talking about web bridge 3. Okay, we are not referencing about web bridge 2 anymore. It's just pure web bridge 3, right? So it is complaining that once again it is some sort of TLS handshake and saying that it is unable to get the local issuer of the certificate. Once again, it's some sort of trust problem, right? It is not necessary it is going to exactly be the explanation that is written here, that where it is not able to trust. You might need to explore a little bit more, because these logging might be a little general, right? So it'd be a good idea, like I said, to get the packet captures as well, and also to validate the certificates back and forth. Right? For this scenario, you would want to validate the trust store which you have assigned for the web bridge 3 and validate it with the call bridge server certificate. Right? Okay. Moving away from the syslog part. And one other neat area where you can do some basic information check is you have this Chrome WebRTC internals, right? So if you join a meeting using the join URL, and if you have connectivity to that same user, and if you want to check something live, you can always go to Chrome:// internals. This will only come up once the meeting is connected, or at least when the media is getting negotiated. It's only during that time where you will see this page. Otherwise, it'll be just somewhat an empty page which will show up here. And one quick thing you can actually check is the set local description. This is basically your local SDP, right? Your local IP address, port information, or the codec information that you want to share with the far end, right, from the browser. And this set local description on success basically indicates that locally you are able to create that SDP and you are able to set it for that communication. Right? You also have a set remote description. So this is your far end SDP information, right? The codec, the candidate, all that information will be here, right? So if for some reason, if you during media negotiation, if the call fails, this information will go away. So this is not static. After a while, it will go away. Whenever the call gets disconnected, this is going to go away. Firefox based browsers, where you can do about:/WebRTC. And you can do about:/WebRTC, and when you connect to a particular meeting, this page should show up, and you can actually see the ICE candidates and a lot of information here, right? So which is the selected local candidate and the far end candidate, right? Your remote candidate is your CMS call bridge, or perhaps your turn server, which is relaying media. All right. Yeah, you actually have a lot of information here in this page. If you scroll down, I've not shown the entire thing, but yeah, if you scroll down, there's a lot of information like the local candidates and the remote candidates, and you should be able to see a lot of information. Static, but it will be there even after. It's kind of persistent, where this information will be there even after the meeting gets disconnected. So if you click on clear history, it will go away. Up until then, you will have this information here. Okay. With that, we are actually done with the content that we have. I just want to show you a small demo with the CMS web app. I just wanted to show you how the configuration actually looks. So let me just bring up my server here. I hope, is the display okay? Is it? I hope it's not way too small. The font size is okay.
Yeah, it's fine, sure.
Okay, thank you. So I'm just going to connect to my Cisco meeting server, which is running CMS 3.0. Okay, so just to show you WebBridge, as you can see, it auto completes to WebBridge 3. There is no WebBridge 2 here, right? So let's look at the WebBridge 3 here, and just to, for your information, it is version 3.0, right? So now looking at the WebBridge 3, you can see the component is enabled, and you have the HTTPS information here. You have the port, the interface, the private key for that communication, and the full chain certificate, right? Then you have the C2W communication here, the interface, the port, and the certificate key, the private key, and the full chain certificate. Right? And this is the trust store, right? So that we trust the call bridge communication. Let me just show you this certificate here. So this is a full chain certificate, right? So let me show you how it looks. PKI, inspect, and the certificate name is how you can actually see the certificate on the CMS server itself on the CLI. Right? Okay, I'm just going to go to the very top. Okay, so this is where I ran the command and we got the certificate output. We can see the encoded certificate here, right? So just keep an eye on this particular part, right? This basically means this is a certificate which you are going to show here, right? So you can see the serial number with 7700 and things like that. And you have the certificate CN name here, which is your cms3newworld.com. Okay, so this is, let's say, the FQDN of this particular server, and the CN of this particular certificate is this one here. And this has been signed by the CA, TP-WinTP-CA. Okay, this is the CA which signed my cms3newworld.com certificate. And the serial number of the certificate is 770000 ending with 005C, right? So as I said, keep an eye on this certificate, right? I'm just going to scroll down a little bit. As I scroll down, you can see the different DNS names, the SAN entries that I have added here. I'll keep scrolling. Now you see that there is a second certificate tag here, right? Which means the first certificate is over when we reach this line, right? It got over here. So this is the certificate, second certificate, which is part of the same bundle, right? The first one was the server certificate, and the second one is the intermediate root CA or the actual root CA. So in this example, there is intermediate root CA. This is directly my root CA, which is signing the server certificate. So this is the final root CA that we have here, right? So the certificate name, the CN value here is CNTP-WinTP-CA. This is my CA server certificate. And the issuer is again the same thing, right? For a self-signed, for a root CA, or it's always a self-signed sort of certificate that you get here, right? So the entity server certificate is here, and this is your root server certificate, right? So basically what happened is there was an entity certificate, and this is on top of your root CA certificate, right? This is how it actually looked. And if there was an intermediate root server certificate, then it would be placed something like here, right? And if you had multiple intermediate server certificates, then you will have intermediate root CA, let's call it A, and you will have another one B, let's say, and then it'll be placed like this. So it should follow this order on how it was signed, right? So this guy will be signed by intermediate CAA, and the intermediate CAA will be signed by intermediate CAB, and the CAB will be signed by the root CA. So everything should be bundled together. That's what a full chain certificate is. Okay. Now that we have seen the WebBridge configuration, let me show you the call bridge configuration as well. And in the call bridge configuration, the only new part here is your C2W trust store, right? The remaining are always has always been there. The new configuration is your C2W trust store, where I'm actually adding the WebBridge server certificate. I could have added the CA as well, which signed the WebBridge 3 server certificate, but I'm just directly pinning that certificate which I need to trust, right? So you can add the CA as well if required. Now the CLI configuration is what we saw. One last thing that I wanted to show you is the GUI based API that you need to configure. So I'm going to sign into CMS. This is my same server, the UI, just to show you it's running version 3.0, right? I'm going to go to configuration API and I'm going to search for WebBridge. So if you remember, the older configuration was also similar. It's just that you had an additional option to do it from the UI also, where you could do, there was an option to actually set the join URL here, right? It's not available from 3.0. You have to use it you have to set it from the WebBridge APIs. So you have this option API v1 WebBridges. If I go inside this, you can see the WebBridge that I've already created, right? So I can go inside this and you can see the URL C2W CMS3newworld.com and port 9999. So this is the FQDN of my WebBridge 3, and this is the port on which my WebBridge 3 is listening. I'll just show you again. It's a little slow, unfortunately. Yeah. So it's listening on this particular interface, on interface A and port 9999, right? The WebBridge is listening for C2W on port 9999. That is why we have set the port 9999 here. And we are explicitly stating you should use C2W protocol. Once you do this, you should be able to connect to your WebBridge like this, right? Okay, so I'm already signed in with Peter Parker. I like comics, so I'm just gonna sign out. Hopefully it should be able to show you. We have this join meeting and sign in option. I should warn you, there was some LDAP based communication problem that I was facing. So if we hit that, maybe I can show you the syslog as well, right? Okay, it is not happening. So yeah, for this Batman user, as you can see, I have a option to create a new space. So if I click on plus, you get this neat pop-up where you can type in a new meeting name, let's say training, and you can create it, right? So go to this training here. As you can see, there is a guest access and host access, right? So you have different options on how you can join this particular meeting, right? For the user itself, they can just click on this join meeting and we should be able to join the meeting, right? You can mute audio video here. I'm just going to mute the audio so that there's no problems, right? The camera is actually covered. That's why the video is not coming up. And I can just disconnect, but I can show you the rest, right? And if you want somebody to join this meeting as host, you can share this information. And if you need somebody to join as a guest, you can share this information. Okay. And one last thing is, where do you get these CoSpace templates from, right? So I'm going to go back to my API. You can search for CoSpace templates. You can see this CoSpace templates here. So if I expand this, I can see that there are two templates that I've created. So let's go inside one of these templates, the host guest template. And inside this template, I just put a name and some sort of description so that the user can understand what it is, right? It's the same thing that which will actually come up when I click on add, right? Host and guest type meeting controls, right? It's the same thing which is coming up here, right? Now, as you can see, there is an access method or one or more access methods associated here. Can go to this access method. I can see the different access methods associated with it, right? So I have a host access method and a guest access method. These are just names. It is basically the call leg profiles or the call profiles which are associated with these access methods, which actually make a difference, right? So let's try and go inside this host access. So let's say I go inside this, I can see there is a call leg profile which is associated with this particular access method. And just to see what that call leg profile will actually do, you can just click this and it should open up that call leg profile. As you can see, I have enabled all the muting functionality. This is just for testing. So I have set all the muting options as enabled, right? I've set everything to be true. So anybody who joins as a host access method to the same meeting space they should be able to do all these options here, right? So if I go back, if I go to the guest access method and you open up the call like profile for the guest access, I've set all the muting options to be disabled, right? So this is how the change actually affects. And when this user creates a meeting space like this, training 2, so anybody who joins as a host will have the capability to, let's say, mute and unmute all the users there, right? And anybody who joins as a guest might not be able to do that because that is the privilege or the provisioning that was provided for this access method. Okay. Yep, I think we are good. And if we can move on to the questions, if you have any. I'll go ahead and stop sharing. Thank you.
Guys, if you have any questions, you can raise your hand. Probably will unmute and you can ask. Okay, if you don't have any further questions, I think we can conclude the session. And once again, thanks for joining. So we hope to see you tomorrow as well. So we have some more interesting topics to be covered tomorrow.
Let me stop the recording.